Good morning to everybody. DevSecOps in Day1 Tokyo, and this is on the 2021 version. Thank you for your time. This is day one. So I have to show to you the agenda. I'm going to share this from the website. Hope you can see this. Yes, this shows today's program, and it's a little after 9 and opening. And starting from 9:05 and for 60 minutes up until 10:05, and Dr. Tamabechi is going to make an opening remarks and a special lecture. And after that, I'm quite happy to speak to talk about the DevSecOps. And for the very first people who are participating in DevSecOps, and I'll be speaking about 20 minutes and why DevSecOps is so important. Then we have the break, and after that, we like to have Hassan-san to spend about 90 minutes, including hands-on DevSecOps. So that's it. That explained. Let me call up Hassan-san. I'd like to receive a few words from him.
Thank you so much, Ishika. I'm really eager to start the day one as a DevSecOps Days Tokyo event. We're going to have a great speakers next day, and then we're going to cover up a lot of technical content today as well, and talking about DevSecOps, and we're going to talk about some exercise to show and present how it is going to work and what a typical infrastructure it is, and how are we going to use the various tools in DevSecOps environment, and we will continue from that. So we are bringing a lot of experience and knowledge to the community in Tokyo. So our goal, as we're going to talk about more today, our goal is really help the community to improve the resilience and security practices throughout the software engineering practices. So we should be ready, whatever we are doing it, whatever we are working on the software engineering or system development, we will make a resilient system. That's our objective. That's our goal. I'm happy to be part of this event, and we're going to continue to discuss rest of today and tomorrow as well.
Thank you very much, Hassan. So we'll hear from you more later. で、ですね、今日、皆さん、
today, those with us, and actually 318 people actually on YouTube and live connected. Thank you again for your comments, and actually good morning. Yes, I'm glad to receive your tweets and also your questions at any time. Please to help us in this regard. And that said, today, 336 people actually are with us live. And actually, in terms of registrations, the latest number is 1,874. Last year, and actually, we had about 1,500 registrations, so up on 20%. Well, we're so happy to have the extended size. Yes, and of course, and I have studied the list of the participants. Yes, this consists of so many varieties of people. System integrators, those people, pro people actually working for the system integrators, and also we have the security the companies, and of course the user businesses, and actually in IT or in the planning department and others, and the self-employed people. Many of them. And what's interesting is that we have many people coming from the healthcare side. Talking about the healthcare industry, yes, there are cyber threats coming up. Last year, we didn't have so many healthcare people, but actually including the clinic, the private clinical, the people, we are so happy in having so many people. And as for your age factors, well, going through the information, actually, the youngest person is in the second year in the junior high school, 12 years and 13 years old, the youngest the person. I think I'm so happy he or she seems to be quite interested in what's going on. I'm just wondering what happened to you in the school and the classes, but maybe you're going to be listening to the presentations and during the breaks. At any rate, we are going to have more people coming and join us live. Let me introduce the very first speaker. This is going to be Dr. Hideto Tomobechi. Actually, he is a fellow of the NSI Lab at Carnegie Mellon University, is also a cognitive lab, the representative. software development, the actual and hidden history of software development, and also the values, significance. Well, going through the 70s and 80s and DevSecOps, he has lots of experiences in actually in developing a software systems. So he's going to actually share his thoughts in terms of the values of the modern DevSecOps. Without further ado, Dr. Tomovich, please.
DevSecOps Days Tokyo 2021. Welcome everyone. Last year was the first one in Tokyo, and DevSecOps, the concept itself, will be discussed in 2 days, which means I'm not going to talk about that in detail now. However, if you Google DevSecOps last year around this time, probably you couldn't find that much information. However, now if you Google that word now, you can find lots of information about what DevSecOps is. So usually the development takes 4 years. However, when you have to do it in days or weeks or months, so now the security development is embedded into the development cycle so that you can have the very short agile development. So for those who registered here, I think you already have some sort of the idea about what DevSecOps is. However, now this is held in Tokyo. So this is the information exchange for professionals and experts. And I think also there are some people who are wondering what DevSecOps is. So to say, there are general non-professional people. So now that we have the simultaneous interpretation to the talks as well. So in that sense, I think it's for beginners as well. When I say beginners, I mean they are professional in programming areas. However, they might be using the different method. And they are coming from the private companies or the governments. And however, and also they might be people who are involved in development itself or involved in management areas as well. So this conference is for a wider variety of the audience. However, today from the speakers, we will be hearing the detailed information as well. So again, I would say this time we really welcome a wide range of audience. And like last year, this year as well, we are having guest speakers from Japan and also the United States as well. And Miyahara-san is leading this organization. So I would like to talk about that as well. So Miyahara-san is leading the Japanese part. And this time we are having professors from Carnegie Mellon as well. So Carnegie Mellon is one of the leading institutions in this area. In that sense, so I am the fellow of Scilab of Carnegie Mellon University. So I am talking from that position. And I am also the visiting professor at the George Mason University. And I'm also the visiting professor of the Japanese University as well. However, today I am speaking as a fellow of Scilab from Carnegie Mellon University. And there are people who have been doing research in this area, of course, and normally they really do not give talk outside of the institution, and we are also supported by the Japanese government as well. So I'd like to mention that later as well. However, we are supported by the Japanese government, and there are the companies which have already introduced DevSecOps So there are the partnerships with companies as well. So from Scilab, we have Dr. Rory Nair, and the doctor was originally working for the federal government, and we also going to have Junichi Eguchi from the METI. So he is one of the leading person in this area from METI, and we are also going to have Dr. Fujitsu as well. So he is now the congressman. However, actually, I know him from 20 years ago. So I would say he is an active researcher rather than just the congressman. And from INI, Carnegie Mellon University, we have a speaker as well. And also he's a professor of the Scilab as well. So I would say the colleagues are from Carnegie Mellon University. And also we have Michael, so I know him for a long time as well. IBM HTTP was his former workplace. Now he is the partnership of the director. So we have Michael as our speaker as well. And also we are actually fixing our final panelist. I believe we are going to have Nicholas as well. So I think Emilia Harrison knows what's happening to Nicholas. So Nicholas actually just resigned from his position. So there's a various thing going on. So probably it might be difficult for him to talk this year. However, we had him last year. So he is the leading person of the DevSecOps in his organization, so DoD. And when we say agile, people who are doing development in large organization might say agile is only for small projects. However, actually, DoD's system is developed by Agile. I believe that is one of the largest systems in the world, and that is done by DevSecOps. So when we look at the all banking system in Japan, actually, I would say it's smaller compared to the system of DoD. So you now cannot say Agile cannot be used for smaller project. That is nonsense. So if we can have him as a speaker for today, probably he would talk about it as well. However, Liger and Nicholas, we are still not sure if we can have him as a speaker. And Hassan is a SAI director at the Carnegie Mellon University, and until several years ago, so I would say the former the heir of the chief of the staff. So I'm not saying the Carnegie Mellon had some secret contract with the self-defense force of Japan. However, actually, people don't talk about it in public. However, when we had the former chief of staff of the Japanese self-defense force, actually, I think it was on newspaper, and also it was in the white paper of Japanese security as well. So I think it was mentioned that there's the collaboration with Carnegie Mellon University, and the Japanese government made it public. So Japanese government is now creating the cyber command, and also they are trying to find some people and they are doing it publicly. So there's the cyber command and also Carnegie and Mellon has been contributing to that as well. It's not a secret at all. I can talk about it. And I was talking to the Self-Defense Force of Japan and on the Scilab side, so we have the mic and also for the training, SEI, I was doing the training. So SEI has been supporting the training part. So SEI, the technical director, is what he does.
Again, talking about the DevSecOps, and actually I'm involved in since day one. So happy to have Hassan because he has rich experiences. Let me talk about Ellington Wells. Well, I'm representing Scilab, Carnegie Mellon University. That's what I said in the outset. At the same time, Washington, D.C., suburban area, George Mason, CI for cyber. There is the laboratory, and actually, he is a research fellow, a research professor there. Actually, in terms of substance, and he is the top person there. In terms of title, he has executive advisor title as a position. So happy to have Dr. Ellington Wells. Actually, thanks to Dr. Wells, actually, I was able to start working for the George Mason. And actually, DOD, actually, he served in the position of the Assistant Defense Secretary. And actually, he was the CAO, the top information officer. Of course, he is also had the title at the National Defense University, even now. So he has lots of areas, experiences on cyber as a whole, and also resilience. So he is considered to be the top expert. People from China, from Russia, may say something negative about that, but definitely he's one of the top experts in the worldwide. Of course, he used to be an officer in the Navy, but this time we're so happy having him as one of the speakers. And Japan cyber the defense the Carlton McLaughlin actually I do understand that and he is basing himself in Japan for as long as 25 years. And also the organizer, we have Emilia Harrison. I believe that he's going to be one of the speakers. Well, thank you again for this opportunity. I just went through the programs, so Day 1 and Day 2. And when it comes to the DevSecOps, and actually they are deeply involved in the operation and also development. And I'm sure that they're going to share their own experiences. And of course, I, for one, was one of the evangelists. And last year we had DevSecOps on Tokyo last year. And since this event last year, I think the concept, this phrase DevSecOps, and actually is penetrating into the Japan. The sec is important. Security is going to be quite important. Yes, DevSecOps, of course, keeps an emphasis on security. That's for sure. Actually, I have listed up the recent cyber incidents in Japan, just said earlier. But maybe it's not worthwhile for me to go into details, and so I'm not going to do that. At any rate, when it comes to security field or the development of software engineering, of course, is the development side. Carnegie Mellon, of course, has a software engineering institute. And ACIN has been in the central position as an independent and a research organization funded by the federal government. So ACIN actually is enjoying that kind of history. And that's it. When I was at the Carnegie Mellon University, when I got involved in the research activities back then, of course, and I was actually back in 1980s, and I was the graduate student. So now also I graduated from the Carnegie Mellon in 1993, some time ago. And when ACI was being built, I happened to actually live in this place. Actually, on my way back to my place, Actually, from the university, I still remember vividly that this huge facilities are being built thanks to the big fund. I think it started with the STI being initiated by the President Reagan. Actually, there was a kind of the public competition again among the public and also the academic and the private sectors, and Carnegie Mellon University was selected, and the Carnegie Mellon University was given a big fund out of this public competition. With this point in mind, software engineering, of course, back then I am on the side of the computer science. Actually, also I did the same research in Yale before to the Carnegie Mellon University. Computer science, of course, is again on the basic research. It is science, scientific field. Versus software engineering, this is a kind of an applied research field. That is why we, well, at Carnegie Mellon, well, the computer with the computer science building. Actually, this the new building, the SCI the building, and seems to become a so huge facilities. I was so impressed. So computer science basic research. And back then, probably we did not use this cybersecurity as the phrase, but again, back then, a cybersecurity center was being built. US CERT, of course, and the CERT, of course. Talking about CERT, of course, since the meeting days, of course, we hosted CERT. We had a JB CERT. Now it is not US CERT. Actually, it has become independent in the organization. Actually, CERT was established within the SEI. So computer science is my background. And the computers out of that computer science is going to be used, again, SCI, of course, and it's funded by the federal government. So it is going to be used by the federal agencies as well as in the defense in the field. Security, safe and secure operation is going to be quite used. It is going to be the applied research. But right now, again, this has become a DevSecOps, what we call the DevSecOps. But so basic research of the computer science as well as security, applied research. There is no boundaries between these two. Well, it is security, but we need to talk about architecture. What is architecture? With architecture, we are going to actually think about how best we can actually build the computers, including operating systems. Back in 1980s, what I was doing back then was massive Marvel process was the major theme given to me. At the same time, using it was very important point. What we can do. Of course, we have to make operating systems. Of course, I was working for Just Systems, a company called Just Systems. So building operating systems. So I designed a PostgreSQL OS. Actually, it was actually written on partner to the so-called Millennium designed by the Microsoft. I've never seen this actually, but again, my open system and Microsoft's open systems were reported in the same publication. That is an actual architecture story, and how security can be embedded into, of course, has been quite critical since day one in the design process. That was a starting point, and now we are talking about DevSecOps. Whenever we're talking about DevSecOps, and of course, we need to look at the development cycle, the so-called, from the top to down, or from the bottom to the top, one by one, upstream and downstream, and a waterfall approach. Versus DevSecOps is so different. Again, there is security in the cycle in all the process. It is going to be as short as a daily basis or on a weekly basis. Well, you have spent 3 years, 4 years, and after that, you start wondering what's going to happen to security. That is not going to be in operation practice. When it comes to DevSecOps, actually, development operations are going to be having the security to be embedded right from the starting point. So this is, in other words, a story of the computer science itself. Of course, as engineers, and if you are the developers, of course, you have an OS layer. That's what you feel. But when it comes to DevSecOps, actually, Actually, it started involving operating systems to begin with. This is quite important. In other words, the old software parts are not going to become modularized. Well, we used to call it containerized, if you remember those days. In other words, Windows 32 and API days. Back then, actually, the containerization became so critical for the product developers. If operating system is going to be Windows, again, we had to create a middle layer, and actually containerization was taking place on top of that. That's what we used to do in 1980s. This is the activities at the operating system level. Looking at the DevSecOps, it is not just programming methodologies or from the design to the testing and the cycle management consulting like the ideas. Well, you may have those thoughts, but you're wrong there. Actually, at essence, in essence, is on how to build and operate computers. And within that, software on her side, of course, is going to be handled by many people. Of course, there are some activities on the hardware side. When it comes to the cybersecurity world, for example, IoT, vis-a-vis the IoT devices, of course, and attacks vis-a-vis IoT devices have become so serious.
So the other day there was the online conference of Scilab, and so there's the surveillance cameras or CCTVs on the road. So there's I don't remember the number. However, actually the people are talking that there are billions or even more than that. There are a large number of CCTV on the roads, and it's connected to IoT. So if it's a distributed architecture, however, what really have to think about is how to do things with that situation. It's not a development cycle we are talking about what we should do on Linux or the Windows. It's more about how we should create a computational device and how architecture should be designed on that. So that is what I'm talking about in DevSecOps. And Nicholas, if we can have him as the speaker for the conference, so there's something like the capsule which you can put on the airplane as a hardware. So there's the connection of hardwares, and that is another area that DevSecOps are thinking about as well. So from the development to the operation, and also the paradigm of operation, if you think DevSecOps in that way, I think that is what probably that could be one of the perspective probably that you can think about. That is one of the safe the paradigm. However, what I want to say is actually DevSecOps is something more than that. So right process was what we had in the past. So there's the base of the Linux architecture. So at the Carnegie Mellon, Mark was leading the project, and I was in that project as well. So Microsoft and also Apple's, actually that I can say that was the base of the commercial OS, and we had all that history from back then. So that is why the professors from Carnegie Mellon always have been the reading people in that area. So that is why the Carnegie Mellon is receiving the government budget to do research about the next generation computational device. So the core of that now that we really have to think about the security as well. And I think that really represents what DevSecOps is. And actually, we all very much to Google as well, which means when we Google DevSecOps, you can find lots of information, and there's a Kubernetes and also the Google. There's a lot as well, and probably we owe some much to Amazon as well. But anyway, when companies have to do a large-scale development, sometimes it's on cloud. So it's not like the mainframe hardware, which you can show people like this is it. So there is a huge architecture which companies have to create as the space of the information processing, and anyone can access to that. However, of course, companies need security as well. And if that doesn't go well, the loss Google would might be equivalent to the national budget as well. So that is why I'm talking about this. So that there are companies who have to deal with security, such as Google. And so that is why I say that we owe Google, and there are some various layers on it. In that sense, I would say there are big part played by Google in this area as well. Since 1980s, when we were doing the basic research of computational science, so from basic research to applied research and also the commercialization, there's no boundary between these. And what you are seeing as DevSecOps is the fusion or the combination of these. So basic research and applied research, these are combined in this area. And okay, it's agile. However, I heard that some people were saying that agile is only for small projects. So when Emilia Harrison and I were talking about introduction of DevSecOps to Japanese companies, and some people were talking about agile is for small projects. However, again, DoD, they have the largest development project in the world, and they use this development the method. And so that is why I really have to talk about Google are using this and Netflix are using this in order to make people understood. And they have a numerous number of end users. And if we are talking about the times of the mainframe and the time sharing on device, and that's a different story. However, the very core architecture of a computer stays the same from the older days. So if you are graduate students of the computer science and you learn about the architecture since Turing machine, actually the essence of all these machines are the same. However, now we are in the time of IoT, so there's the hundreds or thousands of things on it, and it's a huge space, and it has to be safe in terms of operation as well, and it has to be developed as well. And it's a rapid development. It's done sometimes in days. And in order to do that, so there are people who develop the huge commercial systems, and I think their contributions are huge. So there's a basic research, applied research, and the commercialization. When I look at this disciplinary, this discipline, the computational science, I see no boundary between these. So this is what I would like you to take a look at. Probably you are someone doing the development of a part of the system of the huge project. However, if you think that way, you shouldn't think that way, which means you should learn the basics of computational science as well, especially when you're talking about cybersecurity. CTF, because CTF, that is what Carnegie Mellon has been doing. So there's the CTF for students, and we are now trying to introduce that to Japan as well. So that's, I would say, early phase education. So how to do hacking, or how we can prevent hacking. So even though you learn that as a knowledge, probably your knowledge will get old in a week. So rather than learning that, you have to learn from the basic how operation system is running, and how operation is done, and there's the application, and now the time is changing as well. So there's the operation and the application system, and you have to understand the basic of these when you work on the coding.
So this has been an essence of DevSecOps, and I hope you fully understand at this point. Another point, if I may. Well, the computer science, the basics, the issues in that field actually have been the foundation for the DevSecOps. Actually, now DevSecOps are being utilized to build large-scale systems. Again, behind that, there is a long history of computer science, particularly since the 1980s. All these evolutions actually are placed into DevSecOps. Of course, so the terminologies we may use could be different depending upon the time. Again, all the things and advanced things and actually were reflected into DevSecOps. If I mean, I'd like to talk about what I did. James Gosling, a little senior to me at Carnegie Mellon, actually, back then, he was working on the browser language, simplified language. It's called Oku. Maybe no one remembers this Oku, but again, on browsers actually, applications and can run. Well, this has become a quite natural thing nowadays. But again, he was assuming that he was just operating the browser. But again, Java code actually came, and that's when it functioned. So the browser, in other words, was behaving like an operating system, and the virtual machines actually being attached to there. And then James, my senior, decided to go to some microsystems actually, and he actually created a Java from that. But my story here is that I was given the money coming from the Japanese government, and back then it was a Lisp, and I think Netscape and actually other browsers, of course, and we actually made our own browser. Our own browsers also and other browsers and actually were covered by our activities, and the Lisp was used and running in the browser. And Lisp, this is a Lisp virtual machine. So I was working for France back then, so we used France virtual machine, just for information. So the Lisp, again, running on the browser, again, through the plugin virtual machine. Actually, it was me, not James, who actually had done that first. I think that I was still teaching at university before I joined the Just Systems. But again, we had a common advisor, Professor Scott Fallman. So he was our advisor back then. Together with Scott, actually, we visited James, and he told us that very flatly, clearly, that well, it is going to be Java, and we're going to go for it. And so, would you please help me? And I said, yes, I got it. And so again, we created Java consortium back then within the Java systems. And I do understand that the Java system, just systems is still acting like acting the secretariat. It was back in the mid 1990s or in the beginning of 1990s. Again, when actually some microsystems actually started its operations, and actually we went visit some microsystems, and consortium got started. Actually, as far as we're concerned, it wasn't Java and the Lisp, quite similar, and the virtual machine. And we use the Lisp to build the operating systems. And then the Sun, gigantic, company is telling us that yes, they're going to go for the Java. If that's the case, why not to join them? I think it was back in the beginning or the mid 1990s. I think I see lots of familiarities nowadays. The basic computer science was covered by us versus when it comes to security. Actually, they work so hard security. And actually, CIA4. Actually, there's not much difference between these two worlds. So Connie Mellon, CLab, and CI and INI. Actually, we were not together. So basic aspect as well as non-basic size, and of course, and some aspects and is having to do with graduate thesis, or also it is going to be able to cover the actual use cases, actually large, the extent and the scale. So all the things are now mixed together, merged into one. Actually, be it Google and Amazon and other large enterprises, Red Hat, Netflix, and as well, they are using DevSecOps. So actually, even DoD is using the DevSecOps. This is the matter of fact, isn't it? In other words, we need to have evangelization in Japan. Yes, we have evangelization in Japan. And back then, of course, and I was helping her, again, vis-a-vis the Java. Now it's time for Japan to have the full engagement in Java DevOps. Okay, the Java language seems to be rather old. But back then, it started when I visited, together with James, when I visited our professor, Scott Feldman. Actually, professor told us, please, to help him, to join him. That's what happened. And this time, and again, this role is given to our host, Emilia Harrison. So now we do hope that yes, we are going to have really a good, a big extended community in this space of DevSecOps, centered around by the leadership and by the Nina Hara-san. Well, probably in 10 years and 20 years, maybe he'll be sharing his bragging story just like I did back in 1980s and 90s and what I did. And then in 20 years, and people may say that, well, it is rather old. But that's the kind of journey I like to get to see going forward. Devops in Tokyo, actually, this is the second year. I do hope that this DevSecOps will become a lot more popular here in Japan. Well, those people who are working in the field, actually, there is no change. You don't need to change the programming language. Of course, you can change it, but actually, you should have no second thoughts moving into DevSecOps. Well, the old style waterfall and approaches, and of course, there are many people and who had worked on the waterfall and approaches. Actually, they are promoted to the top, but it's time for them to change their mindset. Otherwise, no change possible. So, if your presence are not with us, and you should actually encourage them to come and join us. Or those CIO people, maybe you do not have the CIO titles and position, those large enterprises which may have CIOs. Well, now we are having a new Prime Minister, Prime Minister Kishida. Now the government side is actually encouraging the large enterprises who are having the large transactions with the rest of the world. Now the government is telling them that you need to have a director who is also responsible for the economic security. So the economic security is going to be quite important area. So I do hope that you can encourage those types of people come and join us, because now we are having Day1. So I'd like to ask you to encourage them to come and join us. Why? Well, no, I do believe that we are assuming that and they are in the 50s and 60s. I think it's very important for those people to be exposed to whatever going on, whatever what's going on in the computer science. Well, if you are management, maybe you are observing these things from a side. But again, the fact is that DevSecOps contains all these ideas and practices, and we started many years ago. So all these advancements and actually are placed into the DevSecOps. Earlier I was talking about the virtual machine plugin. Of course, the convenience is one of the benefits, but the more important the value is security. Back in 1980s, of course, back then a meeting actually asked us, it was back in the year 1988, and actually they had money. And through the IPA, actually, we were given this fund, and we use a Lisp, nothing but Lisp. Actually, we built an operating systems using this Lisp language. So this is, this was a meeting and the project. Actually, we were asked to make the browsers and all the way to the servers level. It could be in the web servers for the meeting project. It could have been up to the HTTP servers, but and actually we had given that opportunity. We were given that opportunity working on all these important activities, browsers and servers. Actually, of course, in France of the USA helped us in this project. So we are so happy given that an opportunity, and we had a track record there. Why? BPF Bulletproof server. I think toward the end of 1990s and the beginning of 2000, and actually now we are working on it. I think in around 2000, we thought actually now maybe it's time for us to give it up. But now everybody is going to be attacked by in the cyberspace, and so the server is not going to be good enough, and that's what we start talking about, and no one actually showed interest. Actually, development fund actually was 100 millions of yen, but no one actually showed interest back then.
So for servers you operate, these are all developed with Lisp and web server. I did a demo, and for the web server, it was composed of 3 Lisp servers, and the first one is like the Apache for the external, and when there's a get post on browser, it sends the information, and we wrote up to the Apache version at a time, and we reproduce the Apache at a time, and when there's the attack, it can capture that. We wrote that with Lisp, and there were 3 servers, and the reason why there are 3 was we thought it was impossible to modify. However, in case there was some modification, so that there's the HTTP file, and because it was Lisp, so all the lines were one object, and a regular stone was there at the time. And we had the regular object database that we created for ourselves. And the one line means one object. So in those days, the web server's vulnerability was quite simple, which means, let's say there's company a.co.jp/something/something index HTML, and there's the browser URL. And with Linux, or it doesn't have to be Linux, but it is actually like making the announcement about the structure of Linux. There's like this, and there's directly like this, and HTML, and the around 2000, I think it was already commercialized, and in 1980s and 1990s. So the servers are developed at the time. It was the object database, and there's no directory. However, when you access there, it looks like there's the directory, and from the object database to get post, it was generated line by line as a real-time generation, which means if you look at from outside, it looks like there was directory. And if you get into that file system, to my system, actually, it was hashed and encrypted, and it was just in the object database, which means our system could not be hacked because we didn't have the internal system, which was impossible to hack. However, even though it was impossible to hack, we still thought about the risk to be hacked. So that is why we created 2 additional servers to send information out. And one of them looked at HTML all the time, monitor server, and if there's any discrepancy between the original, then it let the other server know, and that server generates the new one from the object database and pass that. So the original web file itself was located outside of the network, which means it was written in Lisp, and the heap space of that server, actually, it is very, very, very difficult to hack that. However, if that happens, in case that happened, so we thought about that and we created the 3 servers. And Lisp was like Java, so there's the VM and the CPU instruction, and it was the possible to separate. However, there was no file space, so there was the infinite memory of a Lisp language, and it was encrypted in the huge heap space. And when there's a get post on virtual machine, HTML lines were generated. That was what happened. So around 2000, I said it's really good, and why don't you use it? However, when I visited our companies, they said we are okay, we are fine with it. We have Apache. However, that was around 2000. However, even now, we want others to use it as well. However, now we really do not have to do that. Now that we have DevSecOps, and based on the development cycle of DevSecOps and Ops, and now we also have the Google layer as well, which means it can be completely separated, and our index HTML system, like it was segregated in the heap space, each module. So for some cases are dependent on CPU, it exists as object. So we had the US-Japan joint project, and there are some the hackers involved in it as well, and it was supported by the METI at the time. However, now you have all these environment, which means in the past, as the basic research, we had to create all of these on OS. And talking about the language, it was Common Lisp. However, in that project, Regular Common Lisp is another thing I was the supporting for the commercialization as well. The France made a REST HTTP server, and I helped it as well, which means that we had to create the environment itself as well. And some engineers were working in that way. That was around 2000, and probably back in 2000, people really didn't know about what cyber attack was. However, if you think about at the top of the Japanese and the authority or the companies, probably that is what they would say back then. However, now you have all of these in the environment. It's all in DevSecOps. And again, for huge development, there have been lots of advanced development activities going on. There are people from the Google, and there are people from the DoD, and there are the people like the Nicholas who have been reading this area. So there's lots of the programming, the paradigm, there's the agile, and now that we have DevSecOps. It's not something like that. DevSecOps is not something that was invented recently. It's more than that. So it's also about if you can operate a system safely, and also that you shouldn't make a mistake by yourself in that operation as well. So at MIT, and also when I was the first year student of the computational science, I learned scheme. So there was no the variable in the language, and I had to do the coding in that environment, which means I was the one of the mandatory subjects if you want to be the professional of a computer science. However, now in this time, you can do anything because it doesn't really give any impact. So again, from all these history, DevSecOps is now what we have, which was born out from the evolution of computer science. And in Japan at IBM, I'm not sure if it's appropriate to talk about IBM here because IBM is not our sponsor for this event. However, I think that was Miki-san, who was the head of the Basic Research Institution. And Toyota, is it okay to talk about Toyota? Okay, so I think that was about 2000. Our server at the time, I think it was a game, METI or other, the ministry. However, I think it was a METI that developed a home server. So we had a project, a home server back in 1980 or 1990s. And talking about the home server, so there was the showcase in Harumi, and that was the time when we had iMode for the mobile phone, and there was Matsushita. So with iMode system, there's a compact HTML. Actually, it's possible to adjust the temperature of your shower. And we were talking about the server which cannot be hacked. So all the access are virtual, there's no files, there's the object database, and it's a real-time generation. So it looks like there's a file Apache, however, there's actually no file, it's just Lisp's working on. And we are talking about the safety. And what really you shouldn't do was adjusting the temperature of a shower. And however, actually next to us, the people were talking about the adjustment of the shower, the temperature by using iMode. And actually that happened. However, what would you do if a hacker set your shower temperature extremely high? So however, anyway, even though there was no terminology IoT, we were talking about that. And there's the Unix command finger, HTML, HTML. And there was the finger, and with the finger, there's the temperature information of the Coca-Cola machine, of the vending machine at one building in the Carnegie Mellon. And so, I mean, the people thought about it. People thought about the adjustment of temperature with that kind of things. However, once again, we were talking about the things in the heap space, and HTTP, with HTTP, that you can get information of the temperature of the Coca-Cola, and this, just like that, the people were talking about the adjustment of the shower, the temperature, and again, the next to my booth in that showcase, the I mode, people were talking about that. And around the time for Toyota, we were talking about the browser for car, and the Shina-san from IBM called myself Shina-san, Miki-san. I think it's okay to talk about that now. So the Shina-san called me, and I visited the Shina-san, and I knew Shina-san, but he was there with the top of the basic research center of IBM, and also there was the professor from the Tokyo University. I cannot say his name. However, what Shina-san said was, "Are you IBM?" I didn't understand what he was trying to say. So at the time, there was the hardware project for AU, and also there was the company, and the president of the company was Maeda-san, and there was the hardware, the project, and also we were doing the computational architecture as well.
Well, for genome computing, actually, Lisp-based systems actually was introduced. Well, then a thread is going to map to 2023, and actually in the normal cases. However, now we're able to go beyond that. So actually, threads was launched at the same time, and based upon that, genome computing actually was the actual use case. I think we were able to actually deliver the hardware to Mr. Maeda's company. Well, you do everything, the hardware, of course, programming. Of course, I was working on this system to replace Lisp programming, and servers and middleware, and also apps, and of course. Then after that, an iMode became format, and actually an entity, and actually ask us to help them creating actually an apps for the format. Yes, so that's what I had done back then. I think that was kind of day one. IBM. He was quite critical about that. I think probably Mr. Shina was asking me to pick up again on some specific other things. Well, we are planning to visit the Toyota Motor Corporation, actually making the server demonstration. Maybe he got that in the information. Maybe that's why he didn't like what I did. Why? I'm talking about DevSecOps. Well, IBM not a sponsor. My apologies. Actually, I have received 1/4 of the fund I need to have to start a Carnegie Mellon. Actually, remaining 1/4 comes from comes from the Japanese government, and also 1/2 comes from the U.S. government. Well, the IBM was talking about Linux, and so what the heck you're talking about? Maybe I should have said that back then. Actually, IBM all of a sudden, again, started moving into the Linux and selling Linux. Just forget about it. And at any rate, again, I'm trying to explain that there is a long history. We have reached this DevSecOps So now the IBM didn't like what I was doing. Actually, they were so furious then about me, and now they were looking at the Linux. And again, we try to actually try to protect everything from the top layer to the bottom layer, and why not to work on the auto servers. So we had some dialogues with the Toyota Motor Corporation, and we are making the virtual machines. Actually, Sony actually approached us. It was back in 1990s. I think toward the end of 1980s, or in the beginning of 1990s, yes, Sony actually asked me to help them run the chip. That is what they are looking at, and to place that into the handycam. Well, actually, the speed was a problem, and usually a lambda chip is going to be inserted. Yes, a lambda instruction. Actually, again, on an improved version, actually, was developed for the sake of the speed factors. Yes. So the lambda chip again built into the handicap and Lisp and AI and business systems. Actually, the current systems is recognize the people's faces. I think that's what we started looking at back in 1980s and 1990s. Wow, with that point in mind, I think Sony is truly innovative company, isn't it? This is a true story. I won't tell you what happened, and in the end, what went wrong was actually former the cell phones actually security was looked at actually in order to protect the chips. We plan to actually introduce virtual machines at the Panasonic, Kyushu, and then others. Actually, all these manufacturers, we actually visited all these in the factories. That's what we said. Well, Dr. Mavichin, actually in the cell phones, actually we are looking at several kilobytes. It is going to be a severe competition, within this module between the software and the hardware side. Now the VMware actually it is going to be gigabit the level. So no way. So it didn't go well. But all in all the things actually are reflected into DevSec on ops. Of course, I'm not the only one making good contributions. Of course, there are many people and worldwide, and a lot of people, and also developers and operators. Actually, lots of efforts and coming from the Stanford University and other universities. Of course, I'm not at liberty to expand on what they did. Japan and the United States, and actually, the efforts actually got started in this journey of DevSecOps. Actually, not 20 years and 30 years. For the past 40 years, all these efforts made in the computer science, again, from the security perspectives, and the development should be reduced based upon such model. And this is actually what we call DevSecOps. So finally, we are getting this fruit. That is why, well, back then, deep in my mind, Java is not first class. Well, I shouldn't go into details. Well, back then, maybe mine is much better over the James because I can have tune and path, and but I decided to help to launch Java the consortium. Actually, the same impact is coming from DevSecOps. So now we have the evangelist for the Java DevSecOps. Mr. Naniohara is the evangelist. Again, not only private sector, but also the public sector. For example, nowadays we're having lots of problems, and as a whole, the entity included. And again, if you are going to be serious to cover IoT, you need to be able to cover the basics, top layers, down layers. Everything needs to be replaced by DevSecOps in order to make Japan as a whole as safe as possible, as secure as possible. And also at stake is going to be the economic and security. I think in this regard, DevSecOps is going to have the biggest impact. Thank you again for this opportunity, and I am truly looking forward to the other speakers' presentation. At any rate, let me introduce the person, one of the executive officers, Emilia Harrison. Would you please come and join us here? Let me introduce Emilia Harrison. He is an official DevSecOps and evangelist. Mr. Nirhara, of course, he has lots of experiences Of course, I'm sure that many of you are quite familiar with his face. But again, to drive DevSecOps, please leverage him, use him, and he should be able to help you in convincing your top management executives. He can play a very important, become a good bridge. Please remember his face, and please remember him. Well, thank you again. Looking forward to the 2 days. Thank you again, Dr. Tomabechi. Thank you.
So Dr. Tomabechi, thank you very much. So now you can see that I'm in a different room. How is it in a different clothes? However, Dr. Tomabechi is very busy, so that is why now we had the recorded the speech from Dr. Tomabechi. And the history of software development, I'm not sure if I would say that was the talk about older days, but it was the actual history. So because I know the history of the development only since when I started to involved in this area, and the deep learning or AI, that was probably from around 6 years ago and 2015, and there are books about that as well. Even though I think I have a good knowledge about this area, when I talked to Dr. Tomapechi, he always said, okay, we actually thought about that 30 years ago. That existed 30 years ago. So which means even though you're engineers, sometimes you are so busy in catching up the latest things, and you really don't know what happened in the past. So in that sense, that was a really interesting speech. Thank you very much. And the next speaker is myself. So, and after my talk, we are taking break. So now there's about 600 audience that we have. Thank you very much for your participation. I'd like to start my presentation. So my presentation is titled DevSecOps for the First Timers. So this is what I'm going to talk about today. Why software matters the most of our history, and what exactly is disrupting traditional business. And we are also going to talk about the software development methodologies, or I think it's better to say a life cycle. So I'm going to talk about what's happening in life cycle and what are winning series for Japan. So these are what I'm going to talk about in about 20 minutes. First, probably this might be familiar to you. So the top 10 companies in market capitalization. So there's tech companies and semiconductor companies, and also the software service is now the core. So Apple, and they also provide the music service as well. And Microsoft has the Office 365, and also the Amazon that they sell goods. However, they have the software service. So the software service is the source of wealth. So you can see the numbers in trillions. So the core values today are software services. And number 6, we have Tesla. When we compare Tesla and Toyota, so Tesla's market capitalization is 5 times bigger than that of Toyota. And the gap is becoming bigger and bigger. So however, in terms of the number of automobiles sold by Toyota, it's much bigger. However, Tesla has EV, and also they have the software as well.
で、これがですね、こういう感じで、まあ何がソフトウェア課金がところで、ビジ
So
ネスモデル上何が一体違うんでしょうかって話なんですけど、
how
トヨ
to
タの場合は、研究開発をして、
do that? So in terms of the Toyota, so they do the research and development about 10 years, and there's the manufacturing and the sales. That is the end of their value chain, basically.
で、研究開で、テスラ
However, for Tesla,
した後、この後、
after sales,
いろいろ続きますよ。
there's various things
ハリケーンが近づいて
continue. For instance,
バッテリー容量を増やすようなソフトウェア
in
構築を
case a hurricane reaches to the area, then Tesla gave some
バッテリー容量をガンと上げられる、もっと充電できるようにしておきますね。停電したら
free software update to
販売後もかかっている。
have more battery use, which means that there's a software update after sales, and also
もちろんホンダも日産もとかそういういろんな
there's some money involved there as well. For Toyota or Nissan,
10年前の
if the car was made 5 years ago or 10 years ago, so I believe they use the most advanced technology of the time car was manufactured. However, for Tesla, because they have a software update, they can always give the
買ったものの
most updated technologies even after sales, and there's the old pilot or the other system which they can give as an update. So even after a consumer purchase a car, they can
ちょうど10年前に
increase or improve their values. And Michael listen so that I be old Netscape when he was 23 years old, and that is Mark Andreessen. And after that, he became the investor,
インクとインとかですね、そういうところの初期の
and he is one of the initial investors for Facebook group on Skype, Twitter, or LinkedIn. And there's
経済的にも変化のまま
the article he said
ソフトウェア企業が経済の
in 2011. So and he said that my own theory is that we are in the middle of a dramatic and a broad technological and economic shift in which software companies are poised to take over large swatch of the economy. And also he said over the next 10 years, I expect many more industries to be disrupted by software. And what happened after 10 years? So about June or July 2020, so Tesla exceeded Toyota in terms of the market capitalization. So that is happening now. So software is eating the world in that sense. So, and he knew that about 10 years ago. So now I am talking about software without giving a definition to it. So for computers, there's hardware. There's a personal computer, and now I have my iPhone on my hand to read your comments. Thank you very much. And there's hardware. And on that, there are OS, Windows, iOS, Linux. And on OS, there are applications, various applications like this. And also when it's connected to the web, so this conference is on YouTube. So it's connected to external web service. So that is why you can watch this conference. So again, and then we have software. There's the operation system, application, and software on the web. So you might think that most of the things here are software, and now lots of things are on cloud. So we say infrastructure as code, IAC. So when there's the hardware, so if it's written in the script as software, then in second, you can use 1,000 or more than 10,000 of hardware on cloud. So in that sense, we can say hardware is a part of software. So again, software is eating the world. So IAC sample code, this is I am involved in Apico CTF, and of course the Carnegie Mellon is involved in this as well. So lots of the things in this code are comments, so I'm not going to talk about what's in the code, but in older days, so when you order a server, you get that 3 months later and you do setup. However, even though you do set up, sometimes the spec is not something you wanted for, and if you would like to have another one, it took another 3 months. However, now with a script, it worked in 10 minutes, and there's the auto scaling in seconds. And so think about Pokemon Go. So there are more than the 1,000 of servers running. And now going back to the market capitalization, so there's the continuing improvement of software, or Kaizen. I think Kaizen is now in the English words as well. So for Google, there are more than 30,000 developers, and there's 45,000 commits per workday, and there's 150 million test cases. And of course, these cannot all be done by human. And because there's continuous improvement, or Kaizen, so that is why there's lots of automation going on. And in terms of the frequency of deployment, so there's the deployment frequency, and also the read time for changes and the time to restore services. These are all looked at. So multiple deploys per day is elite, and for Japanese companies, the situation is something like this.
For example, on Japanese mega banks, well, during the Golden Week or holiday season, actually they are going to have major updates during the spring holiday season, or the year end, or in the beginning of the year. And as for the result time, after they have actually failures, and the common mission actually had cases recently. Actually, the GAFA, of course, sometimes it's going to have some time, but again, as far as the Japanese operators companies are concerned, actually, it took more than 1 or 2 days. So actually, Tokyo Stock Exchange, and actually right before the DevSecOps, actually they had failures. They were not able to open up the market, but they were able to actually fix the issues within 24 hours. So who can be classified as an elite organizations here in Japan? Mercari, for example, of course, they could be in elite. But when it comes to the traditional large enterprises, we will not find the Japanese the companies in elite the genre. In other words, we still have a long way to go compared with the test run. Actually, the gap there is now the 5x plus. So the big difference between Japan side and outside Japan, and this should be further addressed by having a big investment. So what are the specific improvement cycles? Well, the CI and CD are mentioned here, continuous integration and also continuous development. So again, automated software development is going to be the answer. Of course, it used to be nothing but manual, but nowadays it is going to be done in automated fashion. Software development methodologies history is shown here. Back in 1970s, the so-called waterfall approach got started. Back then, phase started from the top and system requirements, then falling down. So it will never go back. The water keeps falling down. Never water will go up. This has been the case of this waterfall model. And of course, they wanted to actually improve the efficiency, and they wanting to actually come up with the best efficiency based upon the well-defined requirements. And of course, this is still the practice, but now the agile development started back in 2001. Well, we're now living in the internet society. Processes and tools and dialogues with individuals will be more important. The fourth point, actually, things have been decided versus actually, new things and changes are going to be more important. And the agile software development declaration was made. Instead of the waterfall, we should go for something else. And in around 2009, DevOps idea came along for the whole system development. Well, for example, in the case of YouTube, functions are going to be continuously extended and expanded. For example, we are using Zoom, and the behavior of Zoom today is somewhat different from the last week. This is quite natural because there seems to be some improvements made over the week. So sometimes this may result in confusion, but again, while developing and operating is going to be done, and they're going to be merged into one. So that was a DevOps, and now cybersecurity has become so critical. So software security needs to be need to be addressed in an automated fashion. It should be placed into the DevOps. Actually, threat is again, what will be the possible threats vis-a-vis the system? Who is going to be an attacker? And in terms of this design, where we may end up with the vulnerabilities. So we are going to actually come up with different ideas, and actually we're going to carry out penetration testing, and the automated test is going to be done. So the updates, well, even if we moved into the production, security patches and are going to be applied in the best frequency. So this has been a cycle behind the DevSecOps. I think this is quite important idea, isn't it? And that is why I have become an evangelist. And also, I'm so happy having collaboration with my co-workers with the Carnegie Mellon University. Well, this is looking into the history of the computer usage by human beings. Well, time is running out. Again, we had waterfall, that was fine back then, but now DevOps and now cyber threats become so serious. Now AI being utilized. Well, talking about AI, and of course, and security is going to be quite important. MLSecOps is one of the recent terminologies. So the process needs to be also automated, and cyber actually attacks overseas and then Japan. Actually, the fact is that we are exposed to all these cyber attacks. Actually, some companies actually went under. Actually, tens of billions of yen. Actually, the value was stolen by North Korea, for example. So the typical DevOps and the system architecture is what you see here. The microservices has been utilized. As you see, each system, instead of making the one big system, why not have each the values? Again, this is going to be for the customer of the care services or the payment system. So again, a service is consists of 5 to 10 people, and Amazon is talking about 2 pizza on the team on the side. Mr. Namori is talking an amoeba management. Well, Google, 20 or 30,000 engineers, and if they are working just in one the big unit, that is going to be no good. So they actually have produced micro the teams, and independent deployability is what they talk about. So within 5 to 10 people, actually the impact is going to be just limited within that space, and through the API and all these microservices are being connected. As you said, this is a collection of so many microservices, and it looks so horrible. But actually, each one of these units and actually is going to be quite an agile DevOps and DevSecOps, and actually came from originally the idea came from the Toyota's the methodology back in 1990s. Actually, Toyota was sitting at the top and worldwide, and actually Lean, the methodology was the theme explained in this publication, in this book. Lean develops Lean and DevOps and science. So the Kaizen has become an English terminology. And actually, we also talk about the Kaizen and Kanban and also Unbound and the DevSecOps nowadays. So these ideas originally came from the Japan practice. That's here Tesla and Toyota comparison. Of course, Toyota is involved in the manufacturing, but again, the Toyota actually, of course, has a Kaizen process, but now Tesla is moving more and more toward a software update, and that is going to be more important for the Japanese the organization. This is a book written by Hassan-san, and if you buy this, you can get to learn more. And if you like to know something about AI, yes, this is a publication I have contributed. Well, unfortunately, time will not allow me to go into details. But again, we have this available on YouTube. Actually, you can talk to Hassan-san. You can talk to the Wellington and Wells rather. And please use this. Please subscribe to this the information. So happy having this day one and day two. Now the summary. Well, the software development capability has become the source of the competitive mission of organizations, and that goes to the defense capabilities of the country. Also, fast and software and improvement cycle is going to be quite important. For that, CI/CD and the system development needs to be automated. Architecture should be microservices. And again, we're now having the shift toward the DevSecOps, and also with this, we should be able to help ourselves in against attacks. The architecture actually needs to be made with higher efficiency, and also the development of the methodologies need to be further addressed. With this much in mind, the culture is going to be important. Growth-oriented culture is going to be important. And the things you have actually made and produced and should be able to they change continuously. So we need to have such a long-term the goals. Of course, we have the Toyota Kaizen, and that should be a basis for the software development of the activities. And so they are the set of objectives I want to share with you. Thank you indeed. If you have any questions, yes, we're quite happy to receive questions and over the system. And also now we can use the Twitter. Yes, thank you again for contributing your the questions and feedbacks. Yes, I keep an eye on the tweets on my device. So if you have any comments, please go ahead. Thank you. Now we're somewhat behind in the schedule. So behind the schedule by 5 minutes. And we'd like to resume the session at 10:35. So we'd like to have the break for 3 minutes and plus. So we'd like to resume session at 10:35. So I'd like to get to see you now in 3 minutes. Thank you.
ビッグデータや AI 技術が脚光を浴びるデータの時代がやってきた。巨大企業もベンチャー企業もデータを大きな経営資源と捉えビジネスに取り入れようとしています。15年以上前からデータ活用の可能性をまっすぐに信じてきた私たち。今こそ一緒にデジタルトランスフォーメーションで開けるドアがたくさんあると思うのです。
持続可能な未来につながる扉、成長し続ける、
できること広がる、データ分析の民主化、
最適な意思決定、
挑戦できる未来、
ささやかな幸せにあふれた日常、
成長です。
ときめく
顧客体験を磨き続ける世界、
豊かな社会、
意味のある仕事を作る、
誰もがビジョンにチャレンジできる、
誰も想像できない
大きな成功、イントゥリアンノン、
目から鱗の瞬間を提供する、
製造の矛盾が子どもたちの未来、
データ×ワクワクイコール未来、できたらいいなを形に、
仲間の笑顔が未来の笑顔を作る。
未来は作るものだというふうに考えているので、仕事を通じて新しい価値をですね、創造すればですね、日本がまだまだですね、成長できる、面白い機会を作ることができると思っているので、かなり広範囲のビジネスをですね、僕らはご支援できるんじゃないかなというふうに思っています。
HRD グループは科学的なアプローチで人事や組織の改革を強力に支援しています。今、多くの企業がデジタルトランスフォーメーションに取り組んでいるのではないでしょうか。デジタルテクノロジー。
はい、では、ちょっと短いお休みでしたけれども、
Welcome back. It was a bit short break, but they would like to start the session. So the session will be done by Hassan, and Dr. Tomabeji talk a little bit about it, and I talk about it about DevSecOps a little bit. But the CI of the Carnegie Mellon University is, I would say, the world headquarters of software engineering. So, and he is the technical director of SEI. This is such the precious opportunity for you to listen his talk. So if you have any question, so if you have some good questions, so I probably can ask the question to Hassan after the session.
I guess it's my turn, right, Yusuka? So I can start?
Yes, go ahead.
All right, great. Thank you for the great introduction. And I was able to hear some of the vocabulary I'm learning. I need to learn Japanese, by the way, from Yusuka somehow. I'm not able to write it. I don't think so I can, but I'm willing to learn some vocabulary from you. So as Yusuka said, I'm a technical director at SEI, and also I'm a faculty member at the Carnegie Mellon University. So I was the first person as the faculty member, as instructors are teaching DevOps courses in the world at the Carnegie Mellon. As Dr. Tomoichi said, Carnegie Mellon is kind of a front runner in the computer science and software engineering principles and practices. And I have started a DevOps course back in 2015. It was the first university in the world as teaching DevOps courses in the graduate level. So we have a lot of information I can share with you today, but I'm going to be focusing more specifically on DevSecOps concept and what it really means, how it started, and how we can achieve some of the capabilities. So at this, if you really get well, we're not really changing engineering principles, first of all. We are not bringing a new way of doing software engineering as we have done it before. What we are really bringing, we are bringing the new principles, new practices. This new principles and practices is really helping the whole life cycle stakeholders. The stakeholders mean whoever has a right to say in the life cycle perspective, such as the acquirers, suppliers, architects, developers, operational people. It is not dev and ops, it is beyond that. It is beyond that means whoever has a right, whoever has any words in the life cycle perspective, they can say or they can talk, or they have an authority to approve, or they have something to contribute it, either users or the financial person or HR person are really involving that practice. That's kind of a differences when we are doing the software engineering right now versus 20 years ago or 30 years ago, the waterfall methodologies. Now the scope is getting much bigger. Now the influences and participation is getting much bigger. It is not just focusing on engineering work. Now we're adding the other elements as well. Okay, so that's really how the DevOps it is. That's what the purpose it is, what the definition is. That's really how it started as well in the community, because as Yusuka said in 2009, and the DevOps terminal and Agile terminology started early days. But Agile is really moving and changing something quickly, delivering into the production environment, but it was very focused on the development practices. It is not covering up the other stakeholders in application lifecycle. there was a reaction came from the Agile community, and to solve that problem, especially from operational perspective, how can we connect the dots between all stakeholders? That means how can we improve the communications? How can we improve the collaboration between the stakeholders? What techniques we have to use? What the problems that we have to solve so we can build up the same application or a same value application we are delivering, and our user will use it and get the benefit of it, or our company make money out of it. So that's how it really started. And it's a reaction to the Agile development practices. And the first time, John Aspel said, and then delivering some functionalities and just work, just write the code. But it's not really thinking about what will happen next. It's more about writing the code and addressing functionalities, having a daily scrum, or having a sprint planner, etc. So goal is really deliver the software faster with new requirements. How it goes to the production, that's not their problem. It is more about focusing on to the requirements. How can I quickly finish up my backlog items, everything else quickly in the life cycle? That's kind of that intentions. When we look at operational people, who are the responsible, make sure that environment is stable. I know in this umbrella, the security is also part of the operational team. We're not saying clearly, but it's part of the operational team. Make sure that our infrastructure is secure, our application is working well, and we are able to manage infrastructure and can support various applications. When we look at these two elements, there is a conflicting interest. One side of the story as a developer perspective, and under developer, there is a business analyst, and there is a development team lead, wants to deliver fast by finishing up the backlog items. Other side of the story says, hold on a second, I don't want to get everything else right now. Let me make sure that my operation environment is stable. I'm not ready to receive any changes that you're pushing to me, and I would like to have the right infrastructure ready to go. I would like to have the right resources that I can push new application, or I should have the new compliance. I should have the security approval that goes into the production environment. That's a really a big blocker moving to the fast in the old mindset, because we cannot really put anything in the production environment without having an approval of the system. What approval means with the security perspective, it is getting very challenging in this day and age right now. As I said, we are responsible. We means like the organizations. When we are building a software, when we are building an application or a systems, we are responsible to make sure secure system that we are building. Nobody will ask that. Usually we're not going to ask anything from us to build up the secure system. That's our job to build up. So with that perspective, we are looking for more stable environment, more reliable environment, more secure environment. You're going to hear a lot of talk tomorrow about the reliability, security, what the techniques are, what the components. You're going to hear a lot of stories as well from different speakers on that topic specifically. Let's continue. So what really the benefits of DevOps is really bringing for us? So I'm going to cover up detail and I'll show an example. If we achieve the DevOps principle, it is going to help us to build up application and reducing errors during development deployment environment. What it really means that if we are building an application, make sure that with application doesn't have any bugs in it, any problems in it. It is important because most of the security problem is based on the defect. When we look at the vulnerabilities, vulnerability is based on the defect. What the defect means, it's an error in an application that we have. The error can be created either an architectural problem, or error may be created in some sort of the not fixing the bug in the systems. If there is a bug in the application that we have, if there is a design problem in application that we have, it is going to open up a vector for adversaries. They will take an advantage of our application using the weakness of the application that we have, attack into our environment. That's the reason fixing any error in the life cycle of the application is really important. How much we can quick fix in the early life cycle, it's going to pay a lot down the road. If we are late to fix any problem late in the life cycle, we're going to pay a lot of money at the end. What the money means? Repetitive work, losing the business, losing our reputations, or paying a fine to the compliance perspective. There are many reasons. So really DevOps is really fixing that type of problem because we are fixing any problems early in the life cycle. And we are creating resilient systems. And our pipeline will be responsive to any business needs, including the outage. And most important, we have a stable system that we are delivering. DevSecOps is not being like going faster, delivering a crappy software. No, it is important delivering a good quality of the product based on DevOps environment. And lastly, it's going to give us a continuous feedback. So when we summarize this concept, it is really bringing us innovation of our application or system that we are building. As Yusika said, why the organization are innovative, like Facebook as an example, or Google? Because they are taking a lot of burden off from the developer, architects, and everybody else using these techniques and principles. So developer, architect have more ability to develop new concepts or learning new technologies or understanding or open up the new concept or getting finding new algorithms. So they're kind of more looking for the new concept because of this infrastructure perspective. So shortly, like if you look at any organizations, and also I did a survey a couple of times in last couple of years, and based on my survey, it was clearly pointing out that if organization is using the DevSecOps principles, engineers has more time to look something new. Engineers has more time to learn something, new language or new concept, because they have enough time, they have enough exploring things they can, because they're not doing the rework in an environment. As we talk about, it's responsive business. And as I said, it is building up a stable and quality systems at the end of the day. I know Dr. Tomechi said at the beginning, we are not changing the engineering principles. It's important. When we look at the engineering principles, there are quality attributes in the life cycle we have to achieve, like architecture perspective, performance, resiliency, availabilities, and security, scalable. These are typical quality attributes. All can be achieved throughout the DevSecOps environment. All right, what are the principles are? So when we look at the principles of DevOps, there are 4 fundamental principles in this concept. I know you may be asking, what is DevSecOps? I'm going to come back shortly, a sec part of it. So there are 4 fundamental principles on this concept. One is having a collaboration between stakeholders. It is important we have to collaborate all the stakeholders, all the project team members. Now we have to ask ourselves, who are the stakeholders? Who are the people are going to help me as an organization? Or who are the people they have to work together, build up a software? So which is important to find out relationship, to remove the barriers between the team members. So I'm going to cut up shortly so we can build up a good collaborative environments. And second element is infrastructure as a code. And Yusuka mentioned as well, and he gave an example too. So I'm going to cover up shortly. What it really means, we have to use the script or a code for every assets we use in our software lifecycle, not just the code. We are writing the code already in a system that we are building. What we are talking about here, the assets means the configuring of the system that we are building, or infrastructure with respect to the VM or environment that we are configuring. It can be a Windows environment, it can be a Linux environment. It doesn't matter which environment you are in. We would like to configure that environment automatically. We would like to create the same configurations how we are using in our development environment. We can replicate quickly in the cloud environment. So all these elements is actually called infrastructure code. So we can script it, we can share the same code over and over and again. And once we build up the good communication and collaboration with our stakeholders, once we have the good infrastructures in place, with the coding perspective, now we need to add two other principles into our life cycle. One is automation. So we have to automate every steps because we can go fast. We can increase the quality of application by testing many, many times. You think that like Google as an example, they're just releasing the software without testing? No, they are doing the millions of tests for their software. And the SpaceX, as the Yusuka said a little bit, they are doing many tests in the hardware simulated environment to make sure that when they have a time to launch the rocket, they have done the testing many times before in advance. So their success rate is higher because they're automating every possible test. But to automate any test, it is requiring these principles. It is requiring to have right infrastructure. It is requiring to have a right collaboration, communication with the stakeholder. And last principle about the monitoring. So we have to really make sure that we are to keep tracking our metrics to validate, improve ourselves. Again, we are building capabilities or a software, and we have to evaluate how are we doing well, or how our system is doing well in operating the production environment. With specific to security, how are we reducing the attack vectors of our environment? How are we reducing the vulnerabilities in our life cycle? How are we having less findings in our code by improving our quality? So these are the monitoring concept. It's important, our principles in our DevSecOps environment. Let's look at closer at each of the principles. We can dive to DevSec. Yes, Yusuka, there's a question. Yes, please.
Some people asking about what are the definitions of security and also resilience. And when you use security, does that mean no incidents or no bug, and also protective against the cyber attacks? So what do you exactly mean by the security?
Great.
And also
great.
resilience.
So there are two things, and security means we have to, based on the risk in our organization or the software that we have, based on the risk, so we can address the known vulnerabilities in our system. So it increase our security of application. Like we are going to make sure that our application is secure is based on the known vulnerabilities, either in a language or a system that we are building. The vulnerabilities can be based on the common weakness enumeration, CWEs, or the common vulnerability exposure, CV. So there are two definitions. We're going to make sure that we are addressing the known vulnerabilities in our application lifecycle. So we have a resilient system at that. If you address the security in your application, your system becomes resilient at the end of the day. If you don't address the security right now based on the risk, and you cannot talk about the resilience. Resilience means you are strong. Your system is strong. It is durable to any attack vectors because you address the security problems, which is vulnerabilities in your application lifecycle. So the good outcome of the security analysis or addressing the vulnerabilities, it is going to help you to be resilient. So that means attackers will not going to attack your system, or it will take longer to exploit your system because you have addressed the problems in your life cycle. Because you address the security problem in your life cycle, your system becomes resilient, and that means attackers will go somewhere else. They're not going to spend the time in your environment because you have addressed the buffer overflow, an example. You have addressed the security in terms of the authentication problem. You have a management in your application. That means application is bug-free, and application is design problem-free. So attackers were not able to exploit your environment, they go somewhere else. Or you are ready because you have built up a resiliency or response plan in your environment. So like a software bill of materials, you're going to hear tomorrow a lot of software bill of materials, and your system becomes resilient by addressing security problems. I hope it was clear.
Yeah, thank you.
It's a long topic. But
yeah,
just
so
going to be
about the resilience, tomorrow we are going to have Dr. Ellington Wells tomorrow, and we'll hear more from him about what is the resilience and how to be resilient. So yeah, please join tomorrow also. So let's go back.
Again, this is a long topic. I know a lot of things, just get the example and what that means. So we're going to hear more tomorrow as well. And I'm going to cover up a couple other talk today as well. All right, so let's go back to the collaboration pieces. As I said, we are looking for many stakeholders. And as an example, these are the typical stakeholders in life cycle, which is operational people and the business analyst and quality assurances and information. These are kind of like a common buckets as the collaborators. What the legal team to make sure that you're achieving or you know your boundaries are. If you are building a software for European community, you have to be following the GDPR regulation, which goes back to the specific for legal issues, an example. So there's a requirements. We have to make sure that we are including these requirements into our daily life cycle. So developer will build up the systems. Again, developer, they know how to write the code, but they don't know what the compliance means. They don't know what the security means either, because that's their mindset. That's how they train. I have been teaching software security at the CME last almost 10 years. And it's a graduate class, and most of the students are coming from CS department. They don't have a knowledge of security. Why? Because security is a living things. Security is more about the learning the new attacks, learning new common vulnerabilities. If I don't have that knowledge as the common vulnerabilities, how can I protect my system, as an example? It's kind of like a building the knowledge and sharing the knowledge, and then talking about the developer level, so developer can address the problem as with respect to the known vulnerabilities. Like we are saying known vulnerabilities, that's exactly, we are saying developer write a better code to address the known vulnerabilities, such as addressing buffer overflow, an example. So that's the reason it's really a good communication, collaboration requiring every stakeholders, right? If you don't communicate and collaborate, it is becoming a silo, it's becoming a completely divided organization unit. And so we cannot really communicate, we cannot really talk to each other. It's like dev team does its own things and IT team has its own things. So it's kind of creating a conflict, creating a different world behaviors. So even though we are in the same organizations, but we're not able to communicate. Even though we are talking the same language, we're not communicating. It's really sad, right? Think about the security, think of the operational team. We are in the same building, but our operational team or security team and SOC team specifically, if they're not sharing any attack information with the developers or architect, and how can we protect our infrastructures, our systems, our software? And attackers already know information about our systems. When it comes to the sharing, we are becoming so protective. We have to really remove the barriers, we have to share, because at the end of the day, we're in the same boat. It is important to sharing and knowledge pieces so we can improve and our quality with respect to security, with respect to other elements as well. So let's continue. Let's look at the infrastructure code much closer. Let's look at the infrastructure code much closer. As I said earlier, infrastructure code is actually a software or the code. It's just a script or maybe writing the code. What it really does, it is creating the environments. That environment can be your server, your infrastructure, your cluster in AWS environment. I'm going to make a demo today. You will see a cluster as an example. It will create an environment from the code. So there will be no manual configuration. You're not going to use the mouse anymore. So you're not going to use the keyboard. You're just going to run it and it will run and continue. That's what will happen actually in an environment. So it will continue and throughout the life cycle that we will be creating. So what it really does specifically, it is really creating the environment and also configuring the application script in an environment. So we are having a same parity and throughout the life cycle that we are talking. So it is a crucial element in the DevSecOps environment because we can make sure that the configuration is correct and we are addressing the security problem in the configuration. And tomorrow we're going to hear more, but I'm just going to say a little bit here. And the configuration items, the code has the dependencies that we are building the software. That dependencies has the version. So exactly we know what type of libraries are we going to use in our provisioning, in our test environment, or a staging environment, or this production environment. So kind of like we're creating ingredients of our systems running in the production environment. Why matter to us? If our environment, if our system got compromised, we exactly know how we construct an environment. So we can really find out the libraries, we can look at the configurations, and we become resilient to respond any outage as quick as possible. Okay, if we don't respond any problems with respect to the known CVEs on that libraries, we cannot be resilient because we'll be hacked already. So it's very crucial, this component. So that's what infrastructure as code does, creating infrastructures, including the environment, including app configuration, automatically from the code that we are writing. We are sharing the same code, and we can test the code. We can make sure that we're using the same components. Let's continue. When we look at the continuous integration concept, so now we are learning to know more about the continuous concept over here. And all days, when we integrate the code, we were just merging the code. We were integrating multiple developer codes, and we are creating binary files or executable files as a result of the build steps. Now we're adding a continuous terminology here. What really means, now we are adding and merging any code changes as soon as when code committed into the repository. So I'm going to make a demo today. As soon as developer commit into the repository, that automatically we can build off the code which is creating the artifact. We are creating deployable artifacts from our build steps. That deployable artifacts has the code, which is binary version or executable version or a package. And we will have any documentation regarding to our production environment. And we're going to have a system artifacts in our environment, and we can push into the next stage for testing, for delivery and deployments. So in all days, we're using a release engineering concept. Now we're expanding that more automatically as a result of using the various build server and techniques. Of course, there's all the principles behind the continuous integration. So we can make sure there are many principles like continuously commit the code, and we have to automate the build steps. We can put a lot of quality gates in the build steps, which is automated testing here, and then we can deploy into the next staging environment. Let's look at the continuous delivery and deployment perspective. So what the delivery deployment means, a continuous delivery is basically taking the software after the continuous integration phase and then put into the staging or testing environment automatically, or manually delivering to the production environment. So in your business case, you don't need to have a continuous deployment, depends on your business needs, but you should have a continuous delivery. So continuous deployment means it's automated process, takes the build from the integration server to the certain testing. As a result of the certain testing, which you can put some parameters into it for security testing and for code quality. I'm going to make a demo. If everything's successful, then application will be deployed into the live environment user can access and use it, which is a continuous deployment. This can be achieved using a same environment throughout the lifecycle. What the same environment means, I'm a developer, I'm using my laptops, and then let's say Yusuke is the tester. Yusuke used the same environment to test my code that I developed it. Then he will look at the different test scenarios and think about he's the kind of a bulletin. He's an expert in the security perspective. He can test the code and he can make sure that I'm able to write the code based on the test scenarios. Then he will say, yes, it's blessed. It will go to the staging environment and goes to production. That's kind of a environment parity should be done behind the scenes so we can deliver a deployment and delivery capabilities. So how is it really done behind the scene? I know we talked about the continuous concept. So let's drill down into what the pipeline means. So far we talk about the common principles. As I said at the beginning, there are a set of principles and practices. The practices are continuous integration, continuous delivery, continuous feedback. These are the set of practices and process that we are talking about. How this is really working, we have to build up a software lifecycle. We have to build up a integrated development pipeline, which is kind of a DevSecOps pipeline we are talking about. In the general concept, each of the software delivery pipeline should have the minimum of these items as you see on the screen. The minimum items should have a repository management in the middle, which is the code repository. Now, we are going to use repository management, not just the code. Now we have to use for infrastructure as a code. We have to use for test scripting. We have to use the build scripting. So we are using the infrastructure code. We are using repository for every artifacts that we are creating in our life cycle. Why matters? Because we would like to communicate. Why? We have to share with everybody else. We don't want to put anything in our laptops anymore. We have to put in the same environment that everybody can access, which is repository management. One example for you guys, then you can really see what's the value, like a GitLab. If GitLab was a perfect example how they grow, how they become a de facto repository management. They use the same techniques for their building an application as a repository management. They did the same thing for themselves by putting the older nodes, old information into the repositories, and they build up a very great knowledge system as the organizations, and everything is recorded, everything is kept as a text in the repositories. Another example, like the Puppet, one example, or the Netflix is another example. Every notes, every content is actually in the repositories. So it is code and plus the configuration, plus the notes, plus the lesson learned. So continuous feedback means we have to get the feedback, we have to collect information, we can put into that environment, a place like repository management, all we can learn. So if you are using repository management, just the code, don't do it anymore. Use the code plus the artifacts. Think about what I can store here, then I can reuse over and over and again, okay? Because everything is going to be packaged together. So a couple other items and that we should have in the pipeline. We should have the continuous integration server, so which is kind of automatically build the code and share the result. We should have the planning tools, which is issue tracking systems, and it may be part of the repositories, but all this component has to connect each other because we don't want to creating a siloed pipeline. That siloed pipeline will enforce the people not to share. So our pipeline should be end-to-end, should be done automatically. So it should be done and integrated so we can get the result. We can see the outputs and we can share it. We can block it. We can trace that. If pipeline is not created properly, we cannot achieve the DevSecOps as well. Like think about the analogy. You are driving the highway, right? If the highway is not created well, and how can you drive in the highway? If highway is going stop and go, or there's a lot of checks, maybe there are a lot of the kind of barriers, maybe there's a narrow roads, maybe it's not connected, you cannot go fast. So your speed will be slow because your highway, which is your software delivery environment, is not configured properly. So we have to really be careful. How are we configuring the pipeline? This is one example that as the minimalistic, we should have all these components, monitoring, source control, code repositories, integrated environment. Here's a quick example for you with the tooling perspective. There are
we get some questions also. Can
yes,
I
please.
pose? And
absolutely, yes.
Yeah, I'll take two questions. One is the
yes,
what is the audience asking about? What is the relationship between two concepts, zero trust and DevSecOps? How does it relate? And then zero trust is part of DevSecOps, or DevSecOps is enabling zero trust, or what is that? And that's the first question. Yeah, go ahead.
Yeah, let me finish up the first question. So that's a great question, and I'm hearing a lot of zero trust. It is the security configuration elements zero trust. DevSecOps is helping to achieve the zero trust much quicker. Why? Because we can build up all this integration, deployment, development practices. We can make sure that we're achieving zero trust in our application that we are building. Let's take a look at this example here. Let's say in our pipeline, we build up an application in our pipeline, right? Here is the source code here. Then we are building the code as using the CI server. Now assume that we build up an architecture component, as Jessica, you said, as well as the microservices. We can build up each of the services as design and with the zero trust concept. That means we're going to trust each other. So within my microservices, it has its own way of communicating, it's its own way of analyzing, has its own way of securing. So we are building an application. How are we going to make sure that we are doing the right things? We can use the DevSecOps process and practices and achieve the zero trust in our application that we are building. We can look at the test perspective. We can monitor how the system is behaving. We can monitor how the container is behaving. More specifically, and you may be using microservices concept, which you have to do. You might be using a service mesh concept, and it's a perfect example for implement zero trust concept, because service mesh will help you to build up the service and build up the control panel and build up the other logging mechanisms, sidecar container. So basically your application service, which is in the microservices pod, we're not going to trust anything, and your control panel in your service mesh will handle that for you. That can be achieved by using the DevSecOps practices and platform. Okay. Next question, is there?
Yeah,
is that
next
clear?
question
Okay.
is about simple question. Is there any DevSecOps as code?
So DevSecOps as code, I would like to say DevSecOps is the set of practices, and it's not good to say DevSecOps as a code, but you may say DevSecOps pipeline as a code. That's a true definition. We may say, if you would like to create this pipeline from scratch as a code, yes, you can do that, because you cannot create a code for your collaboration communication, but you can create a code for your infrastructure. You can repeat over and over and again. And like what that means, like you can build up, and actually I can share a couple of examples. You can build up this infrastructure as a code, and then you can hand over to another team. You'll say, here is your DevSecOps pipeline. Your pipeline means you have a repository management, you have the build server, you have all this tools like the monitoring. You can write the code and everybody can use that. That's the correct definition. So I would like to say you can use the infrastructure as a code as the software development pipeline as a code, or a development pipeline as a code. Actually, I gave a talk in that topic. I call it a DPAC, and development pipeline as a code. Right?
Thank you. So the audience is now raising more questions, and I'll take one more.
Absolutely. Absolutely.
And,
it's good to have that question, Jessica. I like that.
Yes. And the question about this slide, or maybe the previous slide, is about he or she thought that looking at these tool sets and then components, DevSecOps is for larger organization. They might have thought, and then what would happen for the small or mid-sized organization? Do they are they able to implement DevSecOps methodology and life cycle in small to mid organization?
Absolutely, absolutely. DevSecOps is not for the enterprise organization, it's for everyone. It is for the small organizations. And even though if I'm a person, I'm just one person, that's not myself, right? I'm writing a code. I am responsible to build up the secure system. What that means, I'm going to use the GitLab as an example for my repository management. And I have to use the static analysis code either as a part of the GitLab or a free tool, the Sonar Kit, which I'm going to make a demo. One person company should have the DevSecOps practices. So we can basically practice. Now in this context, and I'm writing a code as a freelance to my contractor example, I'm a one person, but I have to practice secure coding. I have to practice the build automation. I have to practice my planning, and I have to practice my better writing the code by knowing the security. It's actually for me, I'm learning. Now we are scaling up to the enterprise-wide, which is the Google level or the Facebook level. What you're really scaling up, you're scaling up hundreds of this pipeline. I think I have a slide, I'm gonna come back. Let me go quickly and show the slide, this one. So what we are really doing we are scaling up this practices 100 times. Like the Amazon has 1,000 pipeline running as a parallel, but the practice are the same. We are using the communication, we are using continuous integration, continuous delivery, continuous deployment practices, but we are using the 100 different pipelines. Each of the pipeline is delivering a specific service, which is a microservice we are delivering as a result. So we are merging of the pipeline to pipeline, we are delivering a product. So it is for everyone. It is not just a big organization, it's for everyone, okay? You may say there will be overhead. but overhead is going to save a lot of time and money down the road because you are facing a lot of security problem as early in the life cycle.
Thank you.
Right.
So let's move on.
So let's go back. Yep. So we were here. So as a result, like combining all this element together, we talk about automation, what automation does, and triggering the kind of like think about the cogs, like turning the gears. That gears is going to build up your application, the continuous integration. It's going to build up your continuous delivery concept as a result of integration. If you look at that trigger, everything starts from the code. As soon as when I write the code is going to trigger the commit. The commit is going to trigger the code review. As a code review, it's going to do the testing. Some of them static analysis testing you do. And some of them you're creating the documentation for your code review, which is your findings. And then you're turning your continuous integration, which is your building. And as a result of the build artifacts, you're running your quality attributes, which is your QA and test for security perspective. And when you're done, you just put in continuous delivery. That goes into your staging environment. Suddenly you're delivering. So this is kind of like a model that you're creating your DevSecOps backend. Okay, if you kind of like create a 4 common principles, remember the 4 common principles. We should have the collaboration, communication. We should have infrastructure. We should have automation. This is the automation piece that we are talking about. Okay, now we are collecting a lot of data through the pipeline, which is going to be more monitoring that we will be talking about. So this is kind of like a core concept. So let's dive into DevSecOps, right? So what does really DevSecOps means? I know we talk about DevOps, basically adding a security into the software development and operational process throughout the life cycle. This is really important. DevSecOps doesn't mean security is in middle. You may say DevOpsSec or SecDevOps, it doesn't really matter. What really matters is adding a security throughout the life cycle, from planning, from the beginning of the requirements until a delivery and deployment. This is end-to-end thinking. Why we are calling DevSecOps, why we drop the kind of DevOps to the DevSecOps? Because as a community, as I said early in my talk, as a developer, as a business need, we always want to go fast and fast and fast. We always want to deliver capabilities because there is a market pressure. There is a need we have to do. And unintentionally, we kind of ignore the security. When we ignore the security, it is paying a lot of dividend for us that it is late in the game. So we have to really fix the security early life cycle. That's the reason, and we call DevSecOps. Actually, I was the part of the community member, still I'm doing a lot of activities. The first time we used the DevSecOps term, and back in 2017, 16-ish, because DevOps was growing, and then we said, we have to open up the community. We have to make sure that, hey, we are doing great for delivering a software. Hold on a second, that's the security. The community of people in RSA conference, we kind of asked the audience, we said, what are you gonna call? Do you wanna call rugged DevOps, secure DevOps, DevOpsSec? What are you gonna call? Everybody said, let's call DevSecOps. So we did a kind of like a polling things. So since that day, we are calling DevSecOps. And then 2 years later, and DevSecOps days started in San Francisco. And now we are in a global event, and Tokyo is one of them we are doing last 2 years because we would like to make sure that we have to build up a secure system. There is no excuse anymore. We cannot really hide any reasons. We cannot say, sorry, we don't have enough time, so we don't have planet. There's no excuse anymore. If something happens in our application, we are responsible for any reason for security. That's kind of our job. And that's kind of our mission as DevSecOps Community Day organizer. We would like to make sure that we are building an application secure way as by default, not after the thought. That's our mission. And that's the reason Yusuke, we were DevSecOps evangelist in Tokyo and in Japan, and I'm happy to support him so we can build up an awareness and Tokyo and all around the world. That's our mission, that's our goal. So let's look at, again, what the security means. As I said, we are building the software and we never really changing the software lifecycle elements. Like when we say the phases, like we are writing the code. When we write the code, but we need to understand what is my requirements to write the code. We have to understand what architecture of my code I'm building. So in agile thinking or a DevSecOps, It is not against anything. It doesn't say you have to drop the requirements. You have to drop the architecture. You just write the code. That's wrong. Still, we do all these phases in our mindset. What we are doing it specifically in the DevSecOps concept, we are adding a feature request, which is the first one. We are adding a feature. But technically, we are adding a feature that how are we building and our capabilities, what is the reason? That feature can be a payment, can be an automated code, something that we're writing the features that we are building. So based on the feature, then we got the requirements, architecture, design, development, test, deliver phases. So each of the phases has the security requirements we have to address. Because as I said, why we are failing, we always do the security somewhere here, like a between a development and test. It is too late to look at the security at this phase. It's not enough. So what really means we have to do security every phase of life cycles. Let's dive into what that means. Okay. So an overall concept that let's combine all the talk so far what we said you have to build up the collaboration communication. Here's your team members. Again, this is an exemplary model. So you have to get a developer, security team, operation team, business, like name it, everybody else. They should really see how are we doing well. They should be able to contribute into the software system that we are building. Everybody has its own contribution. A developer, I'm writing a code. Architect, I'm architecting the system. And operation, I'm maintaining an environment. Security, I am making that I'm building up a secure system as following the guidelines such as NIST and guidelines. I'm a user, I'm going to use it. So everybody has an ability or improvement or input to the environment. But the very important things we should make sure that we are contributing into the system that we are building based on the data, based on the flow, based on the feedback that we receive. What the feedback means? Maybe specific feedback about the specific to the performance related things we make sure that. Maybe feedback is for the vulnerability report that we are finding. Maybe feedback is about the quality of the code that we are writing. Maybe feedback about fixing the error in our applications. There are multiple things that we are collecting. We call that as data. So data is kind of collected throughout the process through the automation perspective, and using this data, feeding back to the feature requirements. Make sure that we are adding a security into the feature requirements. Or make sure that we are designing a replication, we can address the right PKI or right security design. Or we have to make sure that we are addressing the CWEs, which is the code-specific vulnerabilities in the language that we have. Maybe we're going to write a specific testing. So basically, it is kind of like collecting feedback through the automation, feeding back to the team. We learn, we improve the quality of the systems. We learn from our mistakes, we improve the quality. Again, we are learning in life cycle. So let's continue. So let's talk about each of the phases and what type of security problem we may have each of the phases. And I'm going to cover up probably 10, 15 minutes, and I'm going to dive into the demo. Looks like we have about 30 minutes left. So let's start from each of the phases. Said we have to include the security in each phase of life cycle. And you may ask that, do we have to do everything? No, it depends on your organization, depends on your the problem that you are dealing. So you have to find out what is the risk factors that I have to work in this application. Let's say if you're in the healthcare industry, your risk is different than having a small restaurant, as an example. Why it matters? Because in the healthcare industry, you are responsible for saving the human life. In the restaurants, you try to get more business out there, so your risk is different in your organization as the restaurants or healthcare. So you have to really find out what are the possible risks I may have from organizations. Based on the risk, and you will ask yourself, what are the possible things I have to add into my organization as addressing couple threats, which is kind of a knowledge piece. So it's like from the first day, make sure that we are following the governance pieces, we are following the policies, we are following the organization risk factors. So exactly we can find the balance. Again, if we have time, if we have infinite budget, we can build up a secure systems, like complete resilient. And actually, we cannot say completely secure because it depends on the operating system, depends on other the third-party libraries. But more specifically, we are constrained with the time, we are constrained with the budget, and to balance between the time and budget depends on the risk that we have to tolerate. So if you're looking for very secure system, there is a cost associated, okay? So the cost depends on how much risk we can tolerate, and then we have to calculate the impact or the loss of the impact. So based on the risk calculation, so we can invest and time and money, and so we can address specific for each of the functionalities. So let's continue.
I got a
Once
question
we know
from audience. Can I pose?
Yes.
And
yes, please.
Yeah, I also want to ask that question. So I feel it's a good question. So to convince the top management to do this all of types of work, and for example, they need to secure the budget and the people.
Right.
So what is the good way to convince the top management to do all of the things? And
I love it.
Yeah.
Go. I love that question. Yeah, I love that question. Actually, it is very, very important. That's the reason I said the risk at the beginning. Maybe I should open up a little bit here. Organizations, top management knows the risk. What the risk means to top management: losing the company reputations, paying a fine and to the compliance people, or this, let's say the healthcare or the finance sectors. They already know the loss of the business, right? They already know. So what we have to do as a security person, we have to show the impact of the security. If you don't address the known vulnerabilities, what will be the impact? One specific example, let's say you had a website, and top management and will be happy to see the website. Our job to simulate, as an example, if we get a DDoS attack in our website, if we're not able to protect our database by not addressing the right secret authentication in our database, we got DDoS attack and website is not accessible. Top management should know what is the impact of not addressing DDoS attack in our website, and which they already know about losing a business for a day. They already know how much money they can lose, right? If you are selling a goodies in the website, if you don't have a website that's not running for a day, maybe losing a 10,000 customer, that's going to impact our organization. So usually we have to tie the security into our business risk. And almost every business risk has a secret elements. We call it a technical risk and a business risk. What the technical risk is your security related problems, website outage or authentication or cross-site scripting or SQL injection. These are the known vulnerabilities. Impact of the cross-site scripting or SQL injection will cause a damage in a database. Will somebody hack our databases? As a result of this hack, as an outage, we're going to pay the money. We're going to pay the penalty. I'm not really talking about the fixing yet. I'm talking about impact. So we have to really talk about the management as the impact of not addressing the security problems. Impact is very related to the business risks. That's how can we justify the top management. If they know it, 99%, they will say, oh, I don't want to do it right now. Let's go fix it. And I experienced many times. I have been teaching specific to my software security course. And I talked to many CIOs and CEOs. After explaining this one, you know what they said? They said, nobody told me the secret impact to the business perspective. Everybody's talking about, give me your money, I can secure it. But what's the impact? How can we measure the impact? Impact is we have to talk about the risk management team. They already have calculations. We can see the value of not addressing security. They know the impact of losing the business in a day. That's the impact we have to talk about it. Okay?
Yeah, I agree. So the developers should translate their language into business language. That's an important thing. So let's move on, and we probably take questions later on the end of your session.
Right.
Let's save 5 minutes or so then. Yep. Let's move on. Thank you.
All right, let's continue. All right, let's talk about the requirements. So like kind of, and other things you will see on this concept, and each of the activities all relate to each other. So how I really create these activities are, and based on OWASP top 10, and based on OpenSAM, and based on the BSIM, there are known security frameworks out there. So kind of analyze all the security framework, what you see in the slide, and we're going to share the slide as well. This is kind of what I have to do as the engineering perspective, and where I have to address the security, what things I have to do each of the phase of life cycle based on the security framework. That's kind of a combination of all this notion requirements. Now put about the security requirements. So we are inserting the security requirements into our planning. We are adding a text. We are adding a security into our planning as early life cycle. So if you are in the business, you are talking with your users, your customer, you're saying it as I'm going to build up this number of features, but security is also part of it. If you put in advance, everybody like that. If you do later on, you'll say, oops, I forgot to do that. I'm going to do the security requirements and it's going to cost X amount of dollar. 99% you'll get pushback because there is no enough time or there is no enough budget. Ask the money at the beginning. What we are asking the money, we are trying to give the impact analysis. That reason risk assessment is important. We can build up abuse cases is important. So we know that, let's say we passed that hurdle, we have enough budget, we have the security assessment we did. Now we have to convert that knowledge into our daily Scrum or the sprint that we are writing. So technically we are writing a security stories. We are writing a security user requirements abuse cases in our requirement phases and in our planning tools. So technically we are saying, developer, you're writing the function requirement. Here's your number of backlog items. Now here is the security requirements. We have to be addressing that. Now we're kind of adding the requirements into their sprint planning or daily Scrum. They started develop a code and by addressing security requirements. And then as we are building the capabilities, architecting, we are using a third-party libraries possibly. We are using a third-party framework. So we are kind of getting to the operational security team approval of any language that are we going to use. Any operating system has been approved. If you're using any container, we're asking that questions as early life cycle. So operational team or the IT security team, they will have our approved environment for us at the beginning of life cycle. So when we go to the architecture element, based on what we said, the requirements, based on what we said the specifically for the risk, now we are converting the threat modeling that we have done into our architecture design. So basically we are architecting the system to address the known vulnerabilities. What the known vulnerabilities are, and by understanding the common vulnerabilities, literally common vulnerabilities, it's not huge. It's about the 24 common vulnerabilities. Nothing is rocket science. It's actually, I kind of analyze all these vulnerabilities. There are a total number of 24 vulnerabilities, like buffer overflow, SQL injection, cross-site scripting. The language is making a difference. We have many, many languages. We have many types of implementation. The buffer overflow has been known for 15, 20 years. Still, we are not able to address that. What really means to us, we never really pay attention. So the knowledge is there. The common vulnerabilities is there. So we have to look at the common vulnerabilities, architect our systems, and architect our system and make sure that we are designing properly and based on the threat that we are looking for to eliminate and based on the specific vulnerabilities we are going to address in our architecture design. Statistically, if we design the system well, and we are kind of protecting the 50%, we are kind of protecting the 50% of the security problem at the design phase. As I said earlier, the vulnerability is based on the defect. Defect is based on the flaw, which is design problem, or a bug in the system. because adversaries are taking the weakness of our application, which is our design or a bug-related application, to exploit our systems. So if you spend a good time in architecture design phase, statistically, you're eliminating 50% of problem by security design. Like what that means, a quick example, you may use the HTTPS for your communication. You may use the right authentication mechanisms. You may architect your modular. You may put a zero trust in architecture component at this moment. You cannot add zero trust later on. You can add a zero trust in architecture design phases. You can build up your communication mechanisms. You can build up checks and balances in your code, in your module, in architecture phase. That's how it is important to address security in architecture phase, right? So at this moment, when you're creating your architecture, you're going to list off the dependencies and third-party libraries that we are working. And if you address this dependencies list in open source, and you're saving a lot of time at the beginning by identifying what the vulnerabilities are for a known dependencies, which is called a software bill of materials. And Derek Wicks is going to talk about a lot tomorrow from Linux Foundation. I don't want to hijack his talk, but it's good talk that you will hear tomorrow. So when we go into the development phase, now we are kind of converting our knowledge, we are converting our code, and in terms of design, building the system. That's the moment we can write the secure code. So what that really means, like we are writing the code, as I said, not every developer have a perfect understanding for writing the code. We're going to build up the code review practices. We have to train our developers. We have to train ourselves how we can write better code to, and then using the password as a hash or salt stack in our, using the salt and the hash in our code, or password goes into repositories. Or we can build up the proper certification mechanisms in our code that we are writing. Or we can initialize the variables. So every code, every language has its own secure coding practices. So you may say, do you have to learn a lot? Honestly, it's not a lot again. So every code, and if you look at the Python code, actually I looked at the number of security practices. Python code is about the 10 security practices. C++, it's known about the 20-25 known practices. Java, 25-30 practices. So if you get enough experience all these practices by writing the code, you're saving a lot of problem down the road. But we never really pay enough attention. We never really share that. And I strongly advise to your team member, use the cheat sheets. If you are looking for cheat sheets, I developed the cheat sheets for the C++, Java, and Python. I can share all those with you so you can use it in an environment to build up the secure code at the writing the code level. If you're not familiar, if you don't know anything, use the static analysis code, but the static analysis code should be integrated into your IDE. Maybe using Applix, maybe using IntelliJ, maybe Atom, maybe Visual Studio Code. Almost every IDE environment has the capabilities. Look at your code, analyze the code with security perspective, okay? So we kind of, in the middle of the code, we can build up the code right now. And one important thing I would like to mention here, we can build up the unit testing for a specific security functionalities. What type of things we have to address that goes back to our security requirements. Based on the security requirements, we can develop a specific unit testing that we can test our code. So as you can see here so far, we are trying to shift the security to the left. What the left means, we are getting the security from testing or late in the production. We are really moving to the early in the life cycle, look at the business impact, look at the risks, and do the planning. So you can have enough planning at the beginning. We can even have understanding at the beginning, so we can carry out through the life cycle. That's our goal we would like to achieve as moving forward. All right. So let's continue. When we look at the testing, so this is kind of like a most common things everybody does, like most of the organization does, which we have to do some static analysis. We have to do some fast testing as a dynamic analysis, right? Static analysis is the secret application, static application security testing. That means dynamic application security testing. So as I said, most of the organization are doing this type of testing, but what is the problem in this testing with doing wrong? We are testing our application for everything. We have to look at the specific risk that we have to address in our planning. specific risk as the impact. That's the reason our leadership, they don't want to spend so much money because they have to see the impact. So if we know specific security problem we need to address, we have to test those problems in our testing phase. If I know some scenarios for my website, some scenarios are cross-site, maybe SQL injection, maybe session hijacking, we can plan our testing to address the scenarios, which is known vulnerabilities. We are doing the smart way of testing, what I call. So again, we can do the pen testing, we can do fast testing, we can do various testing in this phase, make sure that we are delivering the secure application capabilities. Another point here I have to call out is the monitoring, dependency monitoring, which is another new attack vector is getting very, very, very important. Like we're using a lot of Docker containers, or using third-party libraries. So we are using any third-party framework libraries, but very, maybe a small portion of libraries and container we're using it. But behind the scenes, and adversaries are inserting malicious code into the dependencies and doing some certain things in your environment. Like there are famous things that happen in the container, and folks like adversaries are inserting the data mining malicious code into the container. So you're running a container in your application, but behind the scene, containers also does the data mining in your environment. This is the one example. So we have to monitor everything. We cannot really trust everyone. We have to trust but verify, or we should have a zero trust on dependencies. That's how the DevSecOps practice will help you to facilitate any zero trust concept as well. So maybe look at the delivery perspective, and we will do the container security. We can do the final security review in the delivery perspective. We can certify our code. We can hash our release, and we can make sure that we address all the known vulnerabilities, and we kind of package it so we have authenticate the code so we can release the folks. One example here, like a SolarWinds case happened this year happened, right? SolarWinds was a perfect example how we failed as not delivering the secure application. If we have done properly, we should have protected our infrastructure. We should have the dependencies listed. We should have signed properly, and that we can eliminate any type of vulnerability that has been exposed to the community. And lastly, in this phase, we should be ready for any outage. We are building a resilient system, but it is not guaranteed that that system is going to work forever. So we are building our plan. What the plan means, our incident response plan. So we should be ready for anything may go wrong. That's perfectly fine. If something goes wrong, what is our plan? Do we know all the libraries running in our production environment? Do we know every operating systems? Do we know every version of the operating system? Do we know every version of libraries? Do we know where the code is? Do we have a history of the testing? Do we have the ownership of the code? Do we know the developer's name? Because the time is very, very, very important. If incident happens, we have to fix quickly, as early as possible. Time is clicking. If you don't fix timely for any incidents, it is going to become a 0 day for the adversaries. Even though it's a known things for everybody, it doesn't matter because you haven't fixed your problem. You're leaking. You cannot close the business. If you close the business, you're going to be out of business, right? Sometimes you're going to take the risk, or maybe you're not aware of it. One example, and from Equifax case happened in the US, there was a known vulnerabilities in their production environment, but they were late to address the known vulnerability. It took them 3 months to patch it. 3 months was a heaven for adversaries. They took the 200 million peoples of record. Another example from the Marriott and SPG, they kind of merged together. They were not aware of that they had been hacked. And there was a 6-7 years of data was leaking. They had no plan either. So these are the couple of examples. And we don't want to be your business and kind of attack and got hacked, but you have nothing to do. So you have to plan your response plan at this stage. And finally, when we go to deployment, we have to monitor our production environment so we can really make sure that we are securing environment, we are monitoring. It's important. So I'm going to come back monitoring shortly. So specifically, when we look at the monitoring perspective, data, data, data. It's really important. That's kind of our continuous feedback. We are looking for various data throughout the life cycle. More specifically, for security elements, we can look at. I know we can look at many metrics within other topics. Is the kind of like what type of metrics we have to collect. Metrics depends on your organization. What really matters to you? What is the things you would like to measure it? For a specific security perspective, we would like to measure about attack vectors. We would like to measure our response time. We would like to measure the IPs in stack or the attack or the number of vulnerabilities. We can look at the time to approval. We can look at the time to patch. We can look at the time to release. These are the typical things you have to look at in the security perspective. So we make sure that we are monitoring, so we will alert it. If something is really changing, let's say like the dependency monitoring, if you see some abnormal activities really happening in the life cycle, in your code, in your production environment, these are typical indicators for you that you're not addressing properly. That means you have to look at it. So you may be doing the functional things is correct, but something is running behind the scene. Maybe somebody's stealing your data. Do you have a mechanism to find out that data? Do you have enough measurement that you can monitor your number of SQL queries? Do you have enough measurement to measure your data packet as an example? These are the things you have to put in your pipeline. So that has to be related to what application that you are building and what the contents are you're generating. So it's very important to find out what data is, and you can really share the data and amongst the stakeholders because developers should know that as well. That said, so we are talking about the security as a life cycle end-to-end from beginning to end. This is not just security in middle. So we are spreading security to the life cycle. That's kind of, I give a quick, short runtime. That usually takes about hours to explain. And I give the quick runtime for this component. So I'm going to go to the live demo. I'm going to stop my screen presentation right now. In the meantime, I will take the question as well. Any questions so far for me, Yusika?
Yes, there are tons of questions, and let's go to demo first. Yeah.
Okay, let's go to demo first. All right, let's get a demo first. Okay, can everybody see my screen? Is it too small?
Yeah, a little bit. Make it a little bit bigger, please.
All right, let's make it a little bit bigger. Sure. All right, let's make it bigger. And how about now? Okay. So what I have done it actually, and I built up a exemplary project, and this is exemplary project, and everybody can see. I said, welcome to DevSecOps and DevSecOps Tokyo 2021. This is a basic sprint pattern, which is a Java application. So this Java application is automatically built under a GitLab, which is the GitLab I'm going to use right now as the build. So let's start the build first. I'm going to explain how it is really working behind the scene. So that will usually takes time. So I'm going to go to the source, and this is the code, the Java code, and I will edit the code on live. So instead of saying a DevSecOps Days Tokyo, and I will say, great. And we.
Hassan, can you make the whole screen bigger? Not the Zoom, but the.
How about now? Can you see that? Or you know what? Let me do a quick work. Probably is much better. Let me share my. How about now?
Yes.
Is it better?
Okay. Yeah, that's better.
All right. So I'm going to change the code. Apologizing. All right. Still, can everybody see my screen?
Yes.
Great. We learn how to develop secure code. Okay. So I'm going to take this one. So now I'm changing the message. So what will happen if you look at this picture here, and this will change. Okay, so I'm going to do the quick change in the code in the application. This is kind of like one example of what the continuous deployment is. So we're going to practice the deployment. We're going to deliver that. Let's go to our code, and let's go and update this. Update the message. So I'm going to commit. As soon as when I commit, so now let's go to the pipeline. So what the pipeline will do, automatically grab the code. So can everybody see my screen? All right. So now the pipeline start, what the pipeline is doing, grab my code from the GitLab and then automatically run the code. So let's click here. So what it does, it is looking for the code quality. So I kind of write the code, commit into the repository. So code is in the repository. And now the code quality is running, looking for the specific code quality and how we are doing well in the code perspective. Then it will go to the static analysis, is the SonarQube, then go to the build, go to deploy. As you can see, there are a different stage here. So different stage are, and more specifically, and the stage are testing, stage are building, and stage as the deployment. So we're going to go through each of the stage, and now we build the code. We are doing the test. We're looking for the code, how the code is doing well with the code quality. So what things we are doing right now behind the scene. So I'm going to go to the pipeline one more time here. As you can see, I have done a couple examples here. And with this example, which I did a couple minutes ago, and when you look at the code quality, it's basically analyzing the code and for the known examples. Okay, let's go back here. Let's look at the result and code quality. So look at the code. It says there is a better version to address the some complexity level. Let's say we are looking for the code complexity. We can look at the cognitive complexity and improve our code quality. So basically that's what it does. Then if you're looking for some static analysis, which is the SonarQube, and I'm using the SonarQube to analyze our code with respect to static analysis, which is a secure application, static application security testing. So what it does, it is looking for a known vulnerabilities. So I'm going to click the project and look at the code and see how things is well. And this type of I know there is no bug here, but we can introduce a bug in our code as an example we can do. So let's look at this specifically what the vulnerability is. And I'm going to click here. So it's going to give us an example and what the code has been tested so far. These are the example of the code from Java code and Spring Framework, and we got a score rating as an 8. So what really did behind the scene, and based on the rule in SonarQube, what the rules are, I'm gonna go back to this screen. So these are the rules. That rules are specific to the Java language. So again, as you can see, it's not really a lot, and we are talking about. And in general, we are talking about 15, 20 code practices, but all this practice is adding a rule. So this has been done automatically. So each of the rule is describing a bug, which is the problem you may see in our code, such as not able to address the null value, not able to look at the result, not able to look at integer minimum value, not able to put a default message container. So each of them has an explanation and what the correction of the code example, what the possible solutions are. So theoretically, we can use the static analysis to teach our developer writing a better example. Again, this is the quick things in the SonarQube and how it is running. Let's go back to our pipeline. Let's see where we are. So let's refresh the screen and we just start the test. It looks like we finish up the code quality. We finish up the SonarQube. Now it goes to the build stage right now. So what it does in the build stage, let's look at our GitLab pipeline. This is an example of infrastructure as a code. What this does, it's basically, I know I'm jumping to many screen. I know it's very difficult to maybe get everything else in one shot, but basically GitLab is the repository management. But at the same time, GitLab has its own built-in continuous integration. There was a question at the beginning that you have asked, and can we use the small size company? There you go, you can use a small size company, like 2-3 persons. It's perfectly fine. Can we scale up? Of course you can scale up and adding multiple users into the environment. So what the GitLab does here, GitLab has a GitLab runner, which is a continuous integration server. So what I have done in this integration server, I said, as a result of this build, you have to build up a Docker image, which is the container. That Docker image should have a template, and I'm going to use the templates are, and checking the code quality, and also deploy into the AWS infrastructures. So I'm going to show the infrastructure shortly. So code will be tested. Then after test is done, and it will package it in a Docker container, and then it will be pushed into the AWS instance. An AWS instance will run the container for me, which is the production environment. And you can access from your end as well. If you go to Google, and actually I can share the URL and you can hit the same application. It is completely open to the world right now. So what it does is the build steps. Look at the template, which has been already part of the code quality. And based on my deployment configuration that will go into my AWS environment. So I'm having a secure deployments and having connected behind the scene. And then installing the Docker host with a certain ports and following this stages test and build deployment, and will create a container for me. So what it does basically behind the scene, this is a Java application, and use the Maven package in the Java application and package the jar file, put into the container and push into the AWS infrastructure that will do. So as the steps, we'll do the code quality, and each of the steps will go to the deployment phase. Again, we can add many, many other template here. So let's look at our pipeline once more, and let's refresh again. So that's where we are. So as you can see, it is done in the production. That should be in the production environment. So then we'll click the build. Let's see what happened behind the scene in the build. So what it did in the build, so basically pull the code from a GitLab environments. That let's go back up here. So I know it's a lot of things on the screen. I'm just going to show a couple examples. So what it did, it pulled the package from my code, look at the dependencies, which is my Maven package, and use all the dependencies and pull. And after that, build a target application as a JavaScript application. That's kind of build steps. And download it and configure automatically and compile and test it out. As a result, it created a Docker container for us. So which is kind of our Docker container. It is creating a Docker container for us, put everything into the Docker container as an app jar file. So we'll be in the container. Let's take a look at what happened behind this in the deploy. So let's look at the deployment. So that's another infrastructure as a code. That script is basically grabbing the containers and then connecting the AWS instance. So what AWS instance are, look at here, it says you're going to connect the service. It is your instance. And then you will run the container in that instance, and which is already configured behind the scenes. So we have a secure deployments. So we don't have any keys here, right? Look at the instance, look at the configuration, run the containers. So what it did, and it basically pushed into my instance. This is my instance running in AWS. And eventually the application is running. Let's refresh the screen. It is going to show up. There you go. Great. We learned how to develop a secure code. This is a basic example of running the code from repositories, changing something. Again, I just did a quick example and changing the text version of the header here, like with the puppies. And then so kind of we deploy into the AWS environment, which is our production environment. What we have done behind the scene, so we look at the code quality, we look at the security test and make sure the security test is checked out, and we packaged it and we securely deploy into the environment. That's what we have done so far. So let's look at one more time for Docker file. Here's the example of Docker file. So basically, this one is automatically created, get the code, package it, put into Docker container. Docker container was running in AWS instance. So this is an example. We may put a zero trust concept here so we can make sure that our infrastructure, which is our container, is secure enough. We can use that. Actually, this container is a baseline container and has been used from the Department of Defense. Let me show you an exemplary code. And what is that? Files. And then Docker file. Let's open JDKs and then files. So let's take a look at the JDK file. So actually, I can show you one more step. Docker compose. Yeah, that's our Docker compose file, which is the backend components. So that's how we really created all the files in backend. So eventually use the SonarQube and using our security rules, and we can deploy a test application goes into our path cleaning application. So I know it's kind of a quick thing. So I have the demo. It looks like we passed the time. Maybe if there is any question, we can answer the question, Yusika.
Yeah, let's take a couple of questions.
Sure.
So I'll take this question. So he thinks that, he says, open source is a pretty good culture of the developers, but how there's a trade-off, the open source vulnerability and its convenience and also the security. So how to balance the open source security and also the such trade-off of the convenience and the security of open source?
So there's a way to find the balance. So we have to use open source. I'm not against open source. What we have to do, we have to really understand what are we going to use, where we are using the source. If we know the source, if we know the libraries that we are going to use, it's perfectly fine. But we have to make sure that we are checking, we know the libraries, we know the dependencies. So as long as if we're able to follow the known vulnerabilities of the open source libraries, it is perfectly fine. But the problem is we would like to use, but we never really look at the best practices. We use and we never monitor it. That's wrong. If you look at Docker example, and Docker is a great container perspective, we may use a Docker base image from somebody else, but we have to really careful analyze the Docker base image, make sure that there is no vulnerabilities in it. Use it, but let's analyze it. So what we are saying is like, be smart using the open source and using any tools. What the smart means, we have to document it. We have to put a script. We have to ISS script in our deployments, in our build scripts. We can monitor, we can list these libraries. So if something happens, if we discover new vulnerabilities, we go back and change that. The problem in the developer community, we never, ever trace that. We always use and forget. No, we should not do that. Use it, but we should know that as well. But that's kind of a smart way. Typically, we're asking to create a bill of materials, which is called as a SBOM. We have to create ingredients, which is a software bill of materials that we are going to use in open source. Know it. That's all about we are asking. Know it and monitor it. Let's know the libraries and monitor it. So we should be ready. That's kind of a balance between secure and open source.
Thank you. Probably this is going to be the last question, and unfortunately, so implementing the automation of the testing, for him it sounds like automating the unit testing or integration testing would be okay, but the whole system testing would be a quite big hurdle for him. And then it's about not conducting, but it's hard. The difficulty is about designing the whole system testing. So how would he able to overcome such designing of the system testing?
Perfect. So as we recall that our slide, we said the feature request and requirements in design. So basically we are creating a more modular perspective, like we are creating a microservices concept, or we may be creating a modular of each component. So we have to do the testing in a modular level. We cannot really do the system testing as part of continuous integration every time. However, we can do the specific testing for each modules. So we can do the testing specific to the function module we do. So we can do the integration of each modules and for other components. We call it the system integration testing. So once we do more individual testing for application, we can do system integration testing as in parallel. So typically in a complex systems, we have the sprint for a development for a specific functionalities. We also run a parallel sprint for testing. Like we build up a module, it's good to go, and get another B module, try to integrate both of them, and try to really talk about and how are we testing together. That's how it is going to work out in a system level. So we don't want to wait the system level testing. What we are saying is, do the testing in module level, try to integrate, and do the system testing. So now you may say, if you find any errors, if you do better in our functional, in our modularities, it should be much easier to go back that. There's another things actually, I did not talk specific today, and DevOps is requiring a very modular architecture. Why the Amazon is successful, why the Google or Facebook successful, they have a very modular architecture. They build up a lot of services. I think you said that, Yusika, in your slide about the Amazon example, Netflix example. So they have a lot of services. They kind of create a very loosely coupled architectures that we will do that type of testing. Okay.
So maybe the last question from myself, after listening to your answer. So what would he do start from now, implementing the automation or testing or rebuilding the architecture from monolith to microservices, which would be prioritized to the rebuilding the architecture and also or introducing all the DevOps tool sets and then the environments.
Yeah, I really start from the concept of we call it the V model concept. We're going to start from repositories. When we build up the repository, which is our common source of truth, and with the repositories, that we start to write the code while we are making the modular architecture and try to think about building your pipeline, find out what the build requirements are for your continuous integration, what the pipelines are. So designing pipeline, and it is not a good exercise. We have to design our DevSecOps pipeline will be compatible for architecture. As I said earlier, in various companies, they have hundreds of pipeline because they designed the pipeline for architecture needs. What that means really specifically, in my demo, I presented the Java application is a Java Spring application, which basically a build steps is different for Java code versus the C++ code. So what is really telling me, I can use my build steps for Java is different. I can build up another pipeline for a C++ or the .NET framework. So that's how you design your pipeline for architecture. When you build up modularities, and typical modular architecture means microservices concept, you have a right to choose your technology. You have a right to choose your technology in terms of language and build steps. Then you can build up your deployment delivery pipeline based on what architecture says. So it has to be parallel. Like if I'm building some technology, some architecture, I can build up my pipeline as I go. So we can eventually have a better perspective as aligned perspective. Building the pipeline without thinking architecture is the wrong assumptions. Don't do that. Start as parallel together.
I see. Thank you very much. So we
welcome.
Yeah, we just ran out of time already. So let's close up. Thank you very much. We have to set another time for like a secure in 3 hours. Yeah, and then
I think we need more time. We need more time.
Yeah. So let's do the the kind of like
we should do in person. We should do in person next year. Maybe a 2 day or 2 days. We should do that. I can dive in very details and talk about every steps in details.
Yes, that's right. That's right. And it's yeah. Okay. So let's close down the day one, and so I want to show you the screen. And so tomorrow, so what we have covered today is the 私日本語で喋ります。
Allow me to speak in Japanese. Sorry, I was speaking in English. Again, 9 to 12, we have done this. And as for tomorrow, actually, we're going to start at 8:50. First 10 minutes, well, the Dr. Tomabechin actually who spent 6 minutes in action and will be back speaking about 60 minutes, for 10 minutes rather. Then after that, we are looking forward to all these the prestigious speakers. Actually, hundreds of people actually now here to listen to this experts presentation. Every one of them is going to be so exciting. I hope you keep an eye on us. That's all. Let us now close off day one. And thank you indeed for your time and contributions. That's it. Thank you. Bye now.
ビッグデータや AI 技術が脚光を浴びるデータの時代がやってきた。巨大企業もベンチャー企業もデータを大きな経営資源と捉えビジネスに取り入れようとしています。15年以上前からデータ活用の可能性をまっすぐに信じてきた私たち。今こそ一緒にデジタルトランスフォーメーションで開けるドアがたくさんあると思うのです。
持続可能な未来につながる扉、
成長し続ける、
できること広がる、データ分析の民主化、
最適な意思決定、
挑戦できる未来、
ささやかな幸せにあふれた日常、
成長です。
ときめく
顧客体験を磨き続ける世界、
豊かな社会、
意味のある仕事を作る、
誰もがビジョンにチャレンジできる、
誰も想像できない
大きな成功、イントゥリアンノン、
目から鱗の瞬間を提供する。
製造の矛盾か、子どもたちの未来、
データ×ワクワクイコール未来、できたらいいなを形に、
仲間の笑顔が未来の笑顔を作る。
未来は作るものだというふうに考えているので、仕事を通じて新しい価値をですね創造すればですね、日本がまだまだですね成長できる面白い機会を作ることができると思っているので、かなり広範囲のビジネスをですね僕らはご支援できるんじゃないかなというふうに思っています。
HRD グループは科学的なアプローチで人事や組織の改革を強力に支援しています。今、多くの企業がデジタルトランスフォーメーションに取り組んでいるのではないでしょうか。デジタルテクノロジーを活用することにより、営業やマーケティングの見直し、業務プロセスの自動化が様々な企業で実現されています。では、人材や組織に関してはどうでしょう。一人一人の才能や個性に合わせた適材適所の実現や効果的なコミュニケーションの実践はデジタル化とは無縁の勘と経験に頼っているのが現状ではないでしょうか。このような勘と経験に頼ってきた人事や組織の課題もデータにより解決する時代になってきています。私たちの提供するディスクとプロファイル XT は科学的検証に裏打ちされた人材測定ツールです。一人一人のモチベーションの源泉やそのポテンシャルを見出すことで組織や人材の課題を解決します。全世界でこれまでに6000万人、10万社、日本でもこれまで120万人以上の顧客が効果を実感しているソリューションです。これからのデジタル時代の企業における改革の本質は人と組織のトランスフォーメーションにあると私たちは考えています。HRD グループのディスクとプロファイル XT が組織や人材の改革を可能にします。効果的なコミュニケーションによる組織力向上に興味のある方はディスクで、社内の適材適所の実現や人材のポテンシャルを見出すことに興味のある方はプロファイル XT で検索して、ぜひ一度ホームページからお問い合わせください。